Something peculiar has transpired beyond the sun's corona. In the 72 hours since the celestial body known as 3IE Atlas emerged from its solar conjunction, the telemetry received has compelled even the most reserved astronomical experts to seek explanations that lie far outside established scientific literature. What entered our solar system as a crimson, dust-laden comet from the interstellar void has reappeared with a distinct blue luminescence. This is not a mere tint or a subtle hue, but a vibrancy that surpasses even the sun's own radiant color. Before we delve further into this extraordinary phenomenon, allow me to pose a question that might assist in disseminating this information to those who need to be aware. Where are you currently situated as you listen to this? What is the local time in your location? And have you personally noticed any unusual astronomical occurrences in your night sky recently? Kindly share these details in the comments section below. Please show your appreciation by liking this content, subscribing to our channel for more updates, and if you are eager to contribute to the expansion of this community, consider utilizing the hype button and sharing this broadcast across your social media platforms. Your presence here is greatly valued. Let us now examine the significance of this blue coloration within the current context. When we observe comets, their apparent brightness stems from the reflection of sunlight. The fine particles comprising their dusty envelopes scatter this light. Fundamental physics dictates that dust particles scatter light. This is akin to how Earth's atmosphere refracts sunlight to produce red sunsets. Larger particles tend to scatter longer wavelengths of light more effectively. This is an established scientific principle, a concept covered in introductory astronomy courses. Every comet we have ever meticulously studied, when subjected to solar radiation, has developed a reddish or, at most, a yellowish aura due to the dust within its coma. The sun itself possesses a surface temperature of approximately 5,800 Kelvin, which is the source of its characteristic yellow-white appearance. For an object to exhibit a color bluer than the sun, it would either need to possess a higher temperature than the sun or generate its own light through an entirely different process. Data collected from the Stereo-A spacecraft, the SOHO Solar Observatory, and the CCOR-1 coronagraph aboard the GOES 19 satellite indicate that 3IE Atlas, during its closest approach to the sun on October 29th, became demonstrably bluer than the sun. This contradicts the expected outcome based on physics, which should have resulted in a redder hue, not a more intense blue. These observations were corroborated by multiple independent instruments and spacecraft employing diverse sensor technologies, effectively ruling out calibration errors or processing artifacts. This is genuine data pointing to an event that defies conventional scientific understanding. Avi Loeb published his analysis within 48 hours of these observations, labeling it the 9th anomaly, thereby adding it to a series of phenomena that already stretched the boundaries of probability. His research paper, accessible through various astrophysics preprint servers, meticulously details the thermodynamic implications. The surface temperature of 3IE Atlas, even at its closest proximity to the sun, should theoretically be roughly 1/10 that of the solar photosphere. Cooler bodies naturally emit light with longer wavelengths. This principle, known as blackbody radiation and described by the Stefan Boltzmann law, has been a cornerstone of physics since the 19th century. An object with a temperature 1/10 that of the sun cannot, through thermal emission alone, naturally appear bluer than the sun. So, what could be the cause? Loeb proposes two broad categories of potential explanations. The first, a naturalistic explanation, involves specific molecular emissions. When certain molecules are energized by the sun's ultraviolet radiation, they can emit light at distinct wavelengths that fall within the blue spectrum. Examples include carbon compounds, CN radicals, and molecular carbon, known as C2. These substances can produce a blue glow when sufficiently excited. The primary challenge with this hypothesis lies in the intensity of the observed blue light. The luminescence from 3IE Atlas was so profound that it overwhelmed the reflected red light from its dust particles. This suggests an extraordinary emission of gas, far exceeding anything previously observed from a comet at this solar distance. It would necessitate the comet vaporizing mass at a rate that should have caused visible disintegration. And here is where the situation becomes particularly perplexing. The object did not disintegrate. Imaging from coronagraphs reveals a unified nucleus and a well-defined coma structure extending outwards for 300,000 kilometers, all exhibiting that anomalous blue coloration. If the comet were undergoing catastrophic outgassing sufficient to generate this intense blue emission, we would expect to witness fragmentation. Multiple bright points would be visible as pieces separated, and a field of debris would likely be present. None of these indicators are observed. The object maintains its structural integrity while simultaneously producing blue light that defies straightforward explanation. Loeb's alternative hypothesis, which he cautiously presents as a speculative avenue for investigation rather than a definitive conclusion, involves artificial light sources or excessive internal heat generation. If 3IE Atlas harbors any form of power source, or if it generates heat internally rather than solely absorbing and radiating solar energy, this could account for the blue glow. A heated internal engine, operating at temperatures exceeding its surroundings, would naturally emit light skewed towards the blue end of the spectrum. As for artificial lights, if we are indeed considering such possibilities, their color would be determined by their creators. Now, I recognize that some of you may be thinking that this aligns with previous analyses from the same individual who has been criticized for identifying potential extraterrestrial origins for every asteroid. These criticisms are not without merit. Scientific inquiry demands skepticism, particularly when confronting extraordinary claims that require extraordinary evidence. However, let us carefully consider the changes observed within the last 72 hours. Prior to reaching perihelion, 3IE Atlas displayed a red hue. Multiple observations from ground-based telescopes throughout July and August consistently showed a reddish color, consistent with dust scattering, precisely as anticipated. Then in September, some observers noted a shift towards green, a phenomenon that can occur as gas emissions become more prominent relative to dust. Green is a common color associated with comets, originating from diatomic carbon and cyanogen. Nothing unusual there, but blue is entirely novel. The blue coloration emerged immediately at perihelion, precisely when the object was exposed to maximum solar heating and obscured from direct terrestrial observation. The timing of this event is concerning. 3IE Atlas achieved its perihelion at precisely 11:47 UTC on October 29th. At that exact moment, it was positioned behind the Sun from Earth's vantage point, having been in solar conjunction since October 21st. The only instruments capable of observing it were spacecraft coronagraphs, specifically designed to filter out the Sun's intense glare and study its corona. These instruments were not initially intended for high-precision cometary spectroscopy, nor were they optimized for this specific type of observation. Yet collectively, they registered the same phenomenon. Blue. The rapid increase in brightness introduces another layer of complexity. Comets typically brighten gradually as they approach the Sun, following a predictable power law relationship between their luminosity and their solar distance. 3IE Atlas, however, brightened at an accelerated rate, exceeding that of any previously recorded comet. Researchers at the U.S. Naval Research Laboratory described the surge in luminosity as unprecedented, with a brightening curve steeper than any observed previously. Such rapid brightening indicates that energy is being released at an accelerated pace, exceeding what solar heating alone would account for. From where is this energy originating? There exists a possibility that is seldom articulated in academic papers, yet is likely a subject of considerable contemplation. What if the perihelion passage served as a test? What if something was activated? If one were designing an interstellar probe intended to remain dormant during its extended and cold journey through space, at what point would activation be most logical? When would system diagnostics be run and preparations for the mission phase commence? Activation would occur at the point of maximum energy input at perihelion. The system would wait until the solar panels, or whatever power collection mechanism was employed, achieved peak efficiency. And if this power-up sequence involved heat generation, energetic processes, or systems emitting light, then the observed outcome, a rapid brightening and a color shift to blue instead of red, would be precisely what one might expect. I am not asserting this as a definitive explanation, but rather stating that the available data is congruent with this interpretation. Furthermore, We lack sufficient information to definitively exclude it. The pursuit of science is not about embracing comfortable explanations, it is about meticulously following evidence, even when it leads to disquieting conclusions. The current evidence suggests that 3IE Atlas exhibited behavior at perihelion that is inconsistent with that of natural comets. The comparison with previous interstellar visitors offers valuable insight. Oumuamua never displayed cometary activity, nor did it develop a coma or exhibit a color change, as it lacked the volatile compounds necessary for outgassing. Borisov, in contrast, behaved like a typical comet throughout its passage, displaying a reddish hue, predictable brightening, and standard tail development, everything in accordance with established models. 3IE Atlas, however, is neither of these. It possesses cometary characteristics, a coma, a tail, and evidence of outgassing. Yet the specifics are anomalous. The observed chemistry is atypical, the behavior is aberrant, and now the color is inexplicable. There's another crucial element to consider. The blue color was not uniformly distributed. Images captured by the Punch satellite constellation, processed by citizen scientists within hours of their release, revealed a structured pattern within the blue luminescence. It was not merely a diffuse glow, but displayed variations in intensity across the coma. Structured emission implies structured sources. Random outgassing from a chaotic cometary surface would typically result in a relatively smooth brightness distribution, perhaps with some visible jets, but not geometric patterns. While the processing is preliminary and the images are inherently noisy, several independent analysts reported perceiving what appeared to be discrete points of light within the coma, points that were bluer than their surroundings. If these observations are substantiated through more rigorous analysis, we face an additional scientific challenge, as this is not consistent with known cometary behavior. The color blue itself signifies high energy. Photons in the blue portion of the spectrum carry more energy than those in the red spectrum. To shift emission from red to blue requires an input of energy into the system. Solar heating certainly provides energy. However, this energy should theoretically produce a thermal spectrum, a black-body curve that peaks in the infrared for an object of this temperature and extends into the visible spectrum as a reddish glow. Blue emission, therefore, necessitates non-thermal processes, energy channeled into specific excitation mechanisms that preferentially generate high-energy photons. Chemistry is capable of this, as are other phenomena. The most frustrating aspect of this situation is that we missed the critical moment. Perihelion occurred on October 29th. Ground-based telescopes lost sight of 3IE Atlas on October 9th or 10th, depending on the observer's location, as it entered the glare of the sun. It will not be visible again from Earth until November 11th, a full 2 weeks after perihelion, and 2 weeks after whatever significant event transpired. By the time we can direct our powerful telescopes towards it, the crucial moment will have passed. The object will be receding from the sun and cooling down. Any processes that contributed to the blue glow may have ceased. We are left examining echoes, residual effects, and data collected by instruments not originally designed for such detailed observations. The spacecraft that could have provided definitive answers, the Mars Reconnaissance Orbiter, equipped with its high-resolution imaging science experiment, high-rise camera, observed 3IE Atlas on October 2nd and 3rd from a distance of merely 30 million kilometers, offering a resolution 3 times superior to that of the Hubble Space Telescope. However, that invaluable data is currently inaccessible, ensnared by a government shutdown and bureaucratic impediments. Avi Loeb has been vociferously advocating for its release for the past week. Congresswoman Anna Paulina Luna has formally addressed NASA, demanding its immediate disclosure. As of this morning, no action has been taken. We are left with pixelated coronagraph images displaying blue where red was expected. The high-resolution data that could potentially elucidate these anomalies is reportedly stored on a server, either classified, embargoed, or simply lost amidst the administrative disarray of a government struggling with basic operational continuity. Consequently, we are confronted with an unexplained, unprecedented, and seemingly impossible blue. This color challenges our existing understanding of interstellar objects, or, for some, confirms long-held suspicions about what we might eventually encounter. The object is set to reappear in approximately 8 days. Observatories worldwide are already reserving telescope time. The critical question remains whether the blue luminescence will still be present. Was it a transient phenomenon tied to peak solar heating, or did it signify something that activated, surveyed its surroundings, and is now contemplating its next move? The subsequent chapter of this narrative is unfolding at this very moment, at a distance of 30 million kilometers beyond Mars' orbit, traveling at 68 kilometers per second, radiating a color it should not possess. And here we are, earthbound, awaiting November 11th, hoping the blue light will provide answers, yet simultaneously apprehensive that it might present questions for which we are ill-prepared. NASA confirmed 3 days ago that non-gravitational acceleration is indeed occurring. This information appeared quietly within a technical report, devoid of any press release or public announcement, simply presenting dry orbital mechanics data that indicates an anomaly. 3IE Atlas is accelerating without any discernible gravitational cause. The object is altering its velocity and trajectory in ways that cannot be attributed to the sun's gravity, planetary influences, or any other purely gravitational effect. To be precise, every celestial body in space adheres to the laws of gravity. Planets orbit stars, moons orbit planets, and comets follow paths dictated by gravitational fields as they approach and recede from the sun. These orbital paths can be predicted with remarkable accuracy. Given an object's position and velocity at a specific moment, along with the masses and locations of surrounding bodies, it is possible to calculate its future position years in advance, with an error margin of mere kilometers. This is the domain of Newtonian mechanics, the standard practice for organizations like JPL, and the method by which we navigate spacecraft across billions of kilometers to achieve precise targets. 3IE Atlas, however, is deviating from this expected path. While the deviation is subtle, it is measurable, persistent, and increasing over time. NASA's orbital analysis has identified 2 distinct components of this non-gravitational acceleration. The first is radial, directed away from the sun, with a magnitude of 135 kilometers per day squared. The second component is transverse, perpendicular to the sun's direction, measuring 60 kilometers per day squared. These are not statistical fluctuations or rounding errors. They represent systematic and enduring accelerations that accumulate over time. It is important to note that non-gravitational acceleration is not inherently mysterious in itself. Comets frequently exhibit this phenomenon. When ice sublimes from the surface of a cometary nucleus, it expels gas into space. According to Newton's third law of motion, this action creates an equal and opposite reaction, propelling the comet in the opposite direction. This rocket effect, known as outgassing, is thoroughly understood, extensively modeled, and entirely natural. We observe it in every active comet. The crucial question, therefore, is not whether comets can accelerate without gravity, but rather whether the observed acceleration aligns with what outgassing alone should produce. Let us consider the physics involved. The radial acceleration, pointing away from the sun, is consistent with outgassing. As the sun heats the sunward side of the nucleus, ice sublimates, and gas is preferentially expelled in that direction. The resulting rocket effect then pushes the comet away from the sun. This is standard textbook physics. However, the magnitude of this acceleration is critical. A radial acceleration of 135 kilometers per day squared translates to a specific thrust, which in turn necessitates a particular rate of mass loss. Calculations can determine the amount of material the comet must be ejecting to generate this observed acceleration. The figures derived are substantial. Avi Loeb, in his latest paper, performed these calculations. For 3IE Atlas to achieve the observed radial acceleration solely through outgassing, it would need to shed approximately 15% of its total mass over the ensuing months. 15%. This equates to billions of tons of material, an object weighing 33 billion tons, losing 5 billion tons. This is not gentle sublimation, it is catastrophic mass loss, akin to what occurs when a comet fragments. It implies a failure of structural integrity, a complete disintegration. Yet 3IE Atlas is not breaking apart. Imaging reveals a coherent object, its coma structure remains organized, and there's no evidence of a debris field, fragmentation, or any sign of disintegration. The transverse acceleration presents an even more perplexing anomaly. A 60 kilometers per day squared acceleration perpendicular to the sun's direction is observed. Outgassing can indeed produce transverse acceleration if the nucleus is rotating and the gas jets are not perfectly aligned with the sun. Imagine a spinning comet with a jet emanating from one side. As it rotates, this jet sweeps around, generating a sideways force. This phenomenon is known to occur. However, the magnitude of the transverse acceleration observed here would require either extremely asymmetrical outgassing or a very specific rotational configuration. Crucially, we have not detected the kind of rotational brightness variations that would indicate such dramatic asymmetry. The light curve is too smooth, and the variations are too subtle. Therefore, we have an object that is accelerating radially at a rate exceeding that of most comets, accelerating transversely at a rate greater than expected, and yet it is not exhibiting the anticipated signs of outgassing that would account for these phenomena. This scenario forms the core of the engine hypothesis. What if the acceleration is not a result of passive outgassing? What if there is an active propulsion system at play? Let us consider how an interstellar spacecraft might maneuver. After traversing the void for potentially millions of years, it enters a solar system. To achieve specific objectives, such as close proximity planetary observations, deceleration into orbit, or positioning for the next stage of its journey, trajectory adjustments are necessary. When would such engines be activated? At perihelion. This is a fundamental principle of orbital mechanics. Applying thrust when an object is moving at high velocity within a strong gravitational field is most efficient. A change in velocity at perihelion results in a significantly greater alteration of orbital energy compared to the same thrust applied at a greater distance. Every spacecraft engineer understands this principle, and every mission that has utilized gravity assists has exploited this phenomenon. 3IE Atlas reached its perihelion on October 29th. The non-gravitational acceleration was detected in orbital fitting calculations that incorporated data from both before and after perihelion. The acceleration parameters exhibited a change, being different after perihelion compared to before. While the change was not dramatic, akin to slamming on the throttle, it was measurable, the kind of alteration one might observe if a propulsion system were activated, performed a burn, and then throttled back down. I am not definitively stating that this is what occurred. However, I am asserting that the data is consistent with this possibility. The alternative explanation necessitates our acceptance that a comet is behaving in ways that comets do not typically behave, while simultaneously evading the predictable consequences of such behavior. Outgassing capable of producing this magnitude of thrust should result in visible mass loss, which we are not observing. Outgassing of such extreme asymmetry should manifest as observable rotational signatures, which are also absent. What we are witnessing is an object that accelerates as if it possesses an engine. The timing of these events exacerbates the situation. The trajectory of 3IE Atlas, as discussed in previous videos, brings it within tens of millions of kilometers of Mars, Venus, and Jupiter. It traverses the inner solar system on a path that is aligned within 5 degrees of the planetary plane. The probability of such an alignment occurring randomly is extremely low, approximately 0.2%. Now consider the non-gravitational acceleration. This acceleration is precisely fine-tuning the trajectory, making subtle corrections that steer 3IE Atlas along a path that optimizes planetary encounters. This is a remarkable confluence of coincidences. Let us contemplate the potential nature of such an engine. We are not referring to conventional chemical rockets, as chemical propulsion is far too inefficient for interstellar travel, requiring fuel-to-payload ratios in the millions, which is impractical. Potential candidates include ion drives, nuclear thermal propulsion, fusion, antimatter, or technologies yet to be invented. Ion drives produce very low thrust over extended periods. The acceleration observed from 3IE Atlas is too significant for ion propulsion, given its implied mass. Nuclear thermal propulsion, where reaction mass is heated and expelled through a nozzle, could generate thrust. While the specific impulse is superior to chemical rockets, the thrust is modest but real. and the fuel efficiency falls within the realm of feasibility for interstellar missions. Fusion propulsion would offer greater efficiency, and antimatter propulsion even more so. Alternatively, the propulsion system might not involve expelling mass at all. The candidates for propulsion are ion drives, nuclear thermal propulsion, fusion, antimatter, or something entirely novel. Ion drives produce very low thrust over very long periods. The acceleration we are seeing from 3I Atlas is too large for ion propulsion given the implied mass. Nuclear thermal could work. You heat reaction mass, you eject it through a nozzle, you get thrust. The specific impulse is much better than chemical. The thrust is modest but real, and the fuel efficiency is within the realm of possibility for interstellar missions. Fusion would be better, antimatter would be better still, or maybe something that does not involve throwing mass out the back at all. Perhaps some propulsion method remains undiscovered, a way to push against the very fabric of space. The primary hurdle with all proposed methods lies in detection. Any engine generates exhaust, hot gases, charged particles, or electromagnetic signatures, something observable. Telescopes should readily pick up emission lines from the working medium, and spectrographs should reveal velocity signatures from expelled material. We do observe outgassing, gas emissions, and spectral lines. However, these observations are consistent with typical cometary activity, involving substances like water, carbon dioxide, carbon monoxide, cyanide, and nickel compounds. The question arises, is this the exhaust of an engine cleverly disguised as cometary outgassing, or is it genuine cometary activity? The engine could be something cold, producing no visible plume, operating via principles we aren't yet looking for. The presence of nickel is particularly intriguing, a topic we will explore further in the subsequent chapter. The crucial point here is that nickel tetracarbonyl is a volatile compound, breaking down when exposed to heat or radiation into nickel atoms and carbon monoxide, both of which are detectable in the spectrum. Furthermore, nickel tetracarbonyl is utilized in terrestrial industrial processes, specifically for refining nickel to high purity, and is not a naturally occurring substance. Its creation requires specific chemical environments and manufacturing processes. If one were to devise a propellant for a thruster, a substance with favorable vapor pressure, storable as a liquid and vaporized on demand, producing a relatively inert exhaust, nickel tetracarbonyl would be a plausible, albeit speculative, candidate. While this is a far-fetched hypothesis, it aligns more closely with the observed data than current alternatives. A more subtle observation pertains to the acceleration vector, which is not random or chaotic. The radial and transverse components maintain specific, consistent ratios over time. If this were merely random outgassing from an irregularly shaped, tumbling nucleus, the acceleration vector would fluctuate, its direction and magnitude varying with solar illumination, the depletion of icy deposits, and changes in thermal lag and rotational state. Instead, we observe a stable thrust vector, suggesting deliberate control. Dr. Daryl Seligman of Michigan State University, a notably more cautious scientist than Avi Loeb, conceded in an interview that the non-gravitational acceleration is unexpectedly large. He characterized it as surprising but not unexplainable, potentially attributable to the comet's unusual composition and volatile content. He is likely correct, as the most probable explanation remains that 3I Oumuamua is a natural comet with peculiar chemistry, leading to unusual outgassing and consequently anomalous acceleration. However, likely does not equate to certain. When a cascade of anomalies accumulates, with the most plausible explanation necessitating the simultaneous occurrence of numerous low-probability events, it prompts a re-evaluation of our interpretive framework. The acceleration persists, even as 3I Oumuamua recedes from the sun, cools, and experiences decreased solar heating. We would expect the non-gravitational acceleration to diminish, as outgassing is primarily driven by solar heat. Less heat should translate to less gas and thus less thrust. If the acceleration does not decrease but remains strong or even intensifies as the comet moves away, this would be exceedingly difficult to explain through natural processes. We will gain clarity in the coming weeks. Observations commencing on November 11th will provide updated orbital data, and the minor planet center will revise the ephemeris. The acceleration parameters will be refined, allowing us to determine if 3I Oumuamua continues to exert thrust, alter its trajectory, and behave as an object with a discernible destination. In the interim, we have NASA's technical documentation, Avi Loeb's academic papers on propulsion systems, and the broader astronomical community diligently recalculating, seeking an error that would invalidate these findings. To date, no such error has been identified. The acceleration is a confirmed phenomenon. The central question is its origin and whether we possess the intellectual fortitude to consider all potential explanations, including the enigmatic presence of nickel without iron and the implications of industrial chemistry in deep space. 4 grams per second is the estimated rate at which 3I Oumuamua ejects nickel into space. This is not a trace contaminant, but a significant quantity streaming away from the nucleus in a plume that defies conventional explanation. Conspicuously absent is the iron that should invariably accompany nickel in cosmic objects. This absence is not a matter of depletion, but of outright missing iron. Dr. Gregory Rogers, a former U.S. Air Force flight surgeon and chief of aerospace medicine at Cape Canaveral, with extensive experience in spacecraft and materials, has stated unequivocally that the composition is impossible from a natural standpoint. His assessment, based on direct experience with the chemical makeup of both natural and artificial celestial bodies, cuts through academic circumspection. Naturally occurring cosmic objects invariably contain both iron and nickel, albeit in varying ratios. 3I Oumuamua, however, exhibits nickel without iron, a phenomenon unprecedented in nature. The genesis of both nickel and iron lies in stellar nuclear synthesis, specifically fusion reactions within massive stars. As stars exhaust their fuel, they forge heavier elements, progressing from carbon and oxygen to silicon, and eventually iron. Iron represents the limit for energy-releasing fusion. The creation of heavier elements necessitates energy input, occurring only during supernova events. Nickel is produced concurrently with iron in these stellar cataclysms. Upon the star's explosion, both elements are dispersed into the interstellar medium, condensing into dust grains and subsequently accreting to form planets, asteroids, and comets, always together. The cosmic abundance ratio of iron to nickel is approximately 18:1. While objects may exhibit iron-rich or nickel-rich compositions, the absence of iron when nickel is present is physically impossible, akin to observing hydrogen without helium. Yet, 3I Oumuamua appears to achieve this. Spectroscopic observations are unequivocal. The Very Large Telescope in Chile detected strong nickel emission lines in the coma, a finding corroborated by multiple observatories. The James Webb Space Telescope's detailed chemical analysis revealed abundant nickel and a striking lack of iron, with upper limits on iron concentration orders of magnitude below what would be expected. This is not a measurement or calibration error. Multiple instruments and techniques consistently report the same findings. The compound being emitted is almost certainly nickel tetracarbonyl, a molecule consisting of nickel bonded to 4 carbon monoxide groups. Its volatility ensures easy evaporation, and it breaks down under ultraviolet radiation into nickel atoms and carbon monoxide, both of which are observed. The critical question is the origin of this nickel tetracarbonyl. On Earth, it is synthetically produced through the Mon process, developed in the 1890s, which uses nickel tetracarbonyl for high-purity nickel refining. Impure nickel is exposed to carbon monoxide gas, forming nickel tetracarbonyl, which is then heated to deposit pure nickel. This is an industrial chemical process confined to refineries, not found in space. Could it form naturally? Technically, yes, under specific conditions involving nickel, carbon monoxide, and appropriate temperature and pressure. Carbon monoxide is prevalent in comets, and nickel is present in cosmic dust. If a comet contained an unusual concentration of metallic nickel grains embedded within its ice, and these grains were exposed to carbon monoxide gas, as the ice sublimated, some nickel tetracarbonyl formation might occur. However, the issue lies in the concentration. We are observing emission rates that imply kilograms of nickel being released daily, necessitating a substantial amount of metallic nickel within the nucleus, far exceeding typical cosmic abundances. Moreover, this scenario still fails to account for the missing iron. If the nickel originated from standard stellar nucleosynthesis, the iron should also be present. Iron also forms carbonyls. Iron pentacarbonyl is a known compound. If carbon monoxide reacts with nickel, it should similarly react with iron, resulting in the detection of both. We observe only nickel. The ratio to cyanide further complicates matters. Cyanide, CN radicals, is common in comets, originating from the breakdown of organic compounds under solar radiation. The cyanide abundance typically reflects the organic chemistry of the nucleus, while 3I Oumuamua exhibits a normal, perhaps even slightly low cyanide level. The nickel to cyanide ratio is orders of magnitude higher than in any known comet. Avi Loeb calculated the probability of this ratio occurring naturally in a comet with the observed composition to be less than 1%. This adds another significant anomaly to the list. Dr. Rogers' point regarding spacecraft materials is pertinent. Satellites and space probes often utilize nickel alloys, not solely for their inherent properties, but for their specific performance characteristics, such as corrosion resistance, high temperature strength, and dimensional stability. In certain specialized applications, nickel is used with minimal iron content, such as nickel 200, pure nickel employed in electronics and specialized components, where magnetic properties or chemical resistance are paramount. If one were to design a spacecraft intended to endure millions of years in interstellar space, withstand cosmic radiation, and maintain structural integrity across extreme temperature fluctuations, material choices might mirror those of advanced terrestrial engineering, favoring high nickel content and low iron to mitigate magnetic interference or oxidation issues. In the event of damage, or if this spacecraft were shedding material or leaking stored volatiles from nickel alloy tanks, the observed nickel emission without iron would be a predictable outcome. This is not definitive proof, but it presents a plausible scenario that aligns with the data. What concerns me is this: we have multiple potential explanations for individual anomalies. The blue coloration could be attributed to ionized carbon monoxide. The observed acceleration might stem from asymmetric outgassing. The nickel emission could arise from unusual yet natural chemical processes. Each explanation, in isolation, is improbable but not impossible. However, these anomalies are not independent. The blue hue, the acceleration, and the nickel emission are all occurring concurrently in the same object. Furthermore, the chemical pathways that might explain the nickel are intrinsically linked to those that could account for the blue color, and both are tied to the energy budget driving the acceleration. Everything interconnects. Either we are observing a comet that is simultaneously exhibiting 8 or 9 independently improbable characteristics, or we are witnessing something where these anomalies are causally linked, all stemming from a single underlying factor that we are failing to recognize because we are predisposed to interpret the object as natural. The water percentage further supports this line of reasoning. Typical comets comprise predominantly water ice, ranging from 50 to 80% water by mass. 3I Oumuamua, however, contains only 4% water, with the remainder consisting of carbon dioxide, carbon monoxide, organics, and evidently, a significant proportion of nickel-bearing compounds. A comet this dry is exceptionally rare, though not impossible. We have encountered comets dominated by carbon monoxide in the past. However, this low water content, while making it an atypical comet by natural standards, renders it a more advantageous spacecraft from an engineering perspective. If one were designing a propulsion system that vaporizes stored volatiles for thrust, carbon monoxide or carbon dioxide might be preferred over water, due to their superior specific impulse and lower mass requirements. The timing of the nickel emission is also noteworthy. Detection occurred during observations in July and August, when 3I Oumuamua was still distant from the Sun. Comets typically exhibit minimal metal emission at such distances, as metal volatilization requires significant heating to vaporize refractory grains. However, nickel tetracarbonyl is highly volatile and can sublimate at much lower temperatures than water ice. If the nucleus harbors pockets of nickel tetracarbonyl, perhaps within subsurface voids, or in the context of an artificial scenario within storage tanks, these pockets could vent early, producing the observed emission before the comet becomes fully active. Adding to the enigma is the anti-tail, a feature observed in the July Hubble image, appearing as a jet of material directed toward the sun rather than away from it. Anti-tails are a known phenomenon, often attributed to optical illusions caused by viewing geometry. However, the anti-tail of 3I Oumuamua is demonstrably real, confirmed by multiple viewing angles as actual material moving sunward. While jets can create this effect, if they are on the night side of the nucleus and rotation brings them into view, this requires very specific geometry, or the material is being actively propelled sunward, perhaps by exhaust from a forward-facing nozzle or reaction control thrusters, performing attitude adjustments. If nickel-bearing volatiles were being expelled as part of such a process, the observed chemistry would be consistent. I must emphasize caution here. I am not asserting that 3I Oumuamua is artificial. I am contending that its observed chemistry is inconsistent with natural celestial bodies, and alternative explanations necessitate assumptions that are individually improbable and collectively unlikely. The scientific method dictates that when a hypothesis fails to align with data, it must be revised. When numerous improbable events must occur simultaneously, alternative frameworks offering more parsimonious explanations should be sought. However, the alternative framework in this instance lies so far outside the mainstream, so profoundly disruptive to our understanding of our cosmic context, that the threshold for acceptance is necessarily immense, as it should be. Extraordinary claims demand extraordinary evidence. Yet, at a certain juncture, an accumulating body of ordinary evidence pointing towards an extraordinary conclusion warrants serious consideration. NASA's stance is unequivocal. Acting Administrator Shaw Duffy responded to a query from Kim Kardashian, a testament to the peculiar avenues of scientific discourse in the year 2025, stating, "No aliens, no threat to Earth." The European Space Agency echoes this sentiment. The prevailing consensus favors a natural comet with unusual characteristics, a view held by highly intelligent and serious scientists, experts in their respective fields. I respect this consensus. However, consensus is not synonymous with correctness. The scientific community once classified Oumuamua as a comet until data compelled a reclassification to asteroid. Similarly, interstellar objects were presumed to be rare until 3 were detected within 8 years. Consensus represents our current belief until compelling evidence mandates a shift in understanding. The nickel anomaly is that evidence, or at least a significant part of it. 4 grams per second of an industrial compound emitted from an object that should not harbor it, devoid of the iron that should be present, and exhibiting ratios that defy natural chemical processes. Something manufactured this nickel, something separated it from iron, and something placed it within 3I Oumuamua. The fundamental question is whether that something was a supernova, followed by billions of years of improbable chemistry, or an intelligent entity with deliberate intent. We are on the verge of acquiring more data. Observations scheduled to commence on November 11th will include high-resolution spectroscopy, allowing us to ascertain if the nickel emission persists, if the observed ratios remain consistent, and if new spectral lines emerge that could illuminate the source. Until then, we are left with 4 grams per second and no satisfactory natural explanation for its origin. The matter of data suppression, the dispute between Avi Loeb and NASA, and the missing Mars images warrant examination. The most critical images of 3I Oumuamua were captured on October 2nd and 3rd by the High-Resolution Imaging Science Experiment, HiRISE camera, aboard NASA's Mars Reconnaissance Orbiter, MRO, as the interstellar visitor passed within 30 million kilometers of Mars. These images offer a resolution of 30 kilometers per pixel, 3 times superior to the best available Hubble imagery. Such photographs could reveal surface features, compositional variations, and structural details that might definitively resolve the object's nature, yet they have not been released. Avi Loeb appeared on the Joe Rogan Experience podcast on October 28th, with the episode airing on October 29th. The 2.5-hour discussion encompassed 3I Oumuamua, the search for extraterrestrial intelligence, and the institutional resistance Loeb has encountered within academia. However, the segment most relevant to this narrative, which has been widely circulated across various platforms, concerns Loeb's comments on the HiRISE images. He expresses palpable frustration, explaining that NASA had a 4-week window to release this data, a period during which the scientific community was deprived of high-quality observations of the most anomalous object ever tracked, and yet the images remained withheld. Joe Rogan suggested Loeb contact the interim NASA administrator, Shaw Duffy, directly. The following day, Loeb followed through, coordinating with Congresswoman Anna Luna, who represents Florida's 13th congressional district, which encompasses Cape Canaveral. Luna has been a proponent of frontier science, advocating for transparency in space exploration, and seemingly taking this issue seriously. She formally addressed Shaw Duffy in a letter dated October 30th, which is publicly accessible online. In it, she urgently requests the immediate release of the HiRISE data, citing its scientific significance and noting that the U.S. government shutdown does not constitute a valid reason for withholding already collected information. As of this morning, November 3rd, there has been no response, no data release, and no acknowledgement. The government shutdown commenced on October 1st. The timing is particularly suspicious. 3I Oumuamua made its closest approach to Mars on October 3rd, precisely when the MRO was optimally positioned and HiRISE was activated. The observations were made just before the government shutdown, leading NASA to enter a state of minimal operations. Consequently, data sharing ceased, not only for 3I Oumuamua, but across all missions. Numerous scientific endeavors are impacted, and researchers relying on NASA data for their ongoing work are effectively locked out. International collaborators are receiving automated bounce-back messages from NASA email addresses. This is not a targeted suppression of information pertaining to 3I Oumuamua. Rather, it is bureaucratic dysfunction affecting all operations equally. However, the concurrence of events, the shutdown beginning on October 1st, coinciding with critical observations, in the same day that ESA's Mars Express and ExoMars Trace Gas Orbiter were also imaging 3I Oumuamua, is noteworthy. ESA promptly released their data. While their images are admittedly suboptimal, designed primarily for Mars surface imaging, and 3I Oumuamua is 10,000 to 100,000 times fainter than their usual targets, rendering detailed analysis challenging. They made the data public. NASA has not. Loeb articulated this situation eloquently on Rogan's show. It is much more likely to be terrestrial stupidity than extraterrestrial intelligence. He is not alleging a conspiracy, but rather incompetence, misplaced priorities, and institutional inertia. NASA is currently embroiled in budget politics, and the scientists responsible for processing and releasing the HiRISE data are either furloughed or working without pay. Decision makers regarding data release are preoccupied with more pressing issues, such as maintaining critical missions and managing the ensuing chaos. 3I Oumuamua, despite being the third observed interstellar object, behaving anomalously and generating intense scientific interest, has become a low priority for NASA amidst these larger concerns. However, the situation becomes more complex when considering that the HiRISE data is not raw, it has undergone processing. The MRO team employs standard pipelines for handling camera data. The images were acquired on October 2nd and 3rd, and a month has now passed, meaning the processing should have been completed. The imagery needs to be prepared in the archive for public accessibility. NASA's guiding principle for lunar missions is the open dissemination of information. All collected data is integrated into the planetary data system within a few months, readily available to the public. This methodology is a standard procedure, mandated by NASA's foundational charter. The information inherently belongs to the public domain. Scholars worldwide utilize this data. Students compile their academic theses based on it. It is neither classified nor considered sensitive. It pertains to Mars. Furthermore, 3I Atlas, while presenting unusual characteristics, does not pose a security concern. It is either a comet or another celestial body on a path that maintains a considerable distance from Earth. It presents no threat, no danger, only scientific curiosity. Therefore, the delay in its release warrants investigation. One potential explanation is that the captured images reveal nothing out of the ordinary. 3I Atlas appears like a comet. Its surface exhibits characteristics of ice. Its form is typical. Its coloration is either reddish or grayish, precisely as one would anticipate. If this is indeed the case, then the question arises, why the reluctance to make them public? Disseminating the data would effectively quell the rampant speculation, providing Loeb and all other interested parties precisely what they are requesting, thereby demonstrating the agency's commitment to transparency. An alternative hypothesis suggests that the images capture something exceptional, and NASA is attempting to formulate a comprehensible explanation before its public disclosure, which would be a sensible approach if the unusual element is scientifically intriguing, but not fundamentally world-altering. If the imaging instruments capture details of expulsion jets, variations in composition, or surface structures that challenge our current models of cometary activity, it would be prudent to organize all findings before the inevitable media frenzy commences. However, an entire month has elapsed. How complex could the necessary explanation possibly be? A third possibility posits that an individual somewhere within the hierarchical structure made a decision to withhold this data, deeming it too sensitive for release without higher authorization, and that this higher authority is currently unavailable due to the ongoing government shutdown. This scenario points to bureaucratic inertia rather than a clandestine conspiracy. An individual seeks to protect themselves, defers the decision-making process, awaits further directives, and consequently, the data remains inaccessible. Loeb believes this is precisely what transpired, as he has openly stated. The operational framework prioritizes risk aversion. No single person wishes to be accountable for releasing controversial data without proper clearance. Consequently, no one initiates the release of any information. Congresswoman Luna's correspondence attempts to circumvent this impasse. She is formally requesting Duffy, the acting administrator, to personally sanction the release. She is providing him with political protection. Her message conveys, "This matter is of significant importance. The public is eager for this information. Scientific advancement necessitates it. Please do the right thing." Whether Duffy will acquiesce to this request remains uncertain. Interim administrators are primarily focused on operational continuity. They are ensuring the essential functions of the agency remain operational, managing immediate crises, and are not inclined to undertake bold initiatives, releasing information concerning an anomalous interstellar object, particularly when a distinguished professor from Harvard is prominently featured on a globally recognized podcast, suggesting it might represent alien technology, is not a risk-free undertaking. It is considerably simpler to abstain from taking any action. Waiting for the conclusion of the government shutdown and allowing the standard procedures to resume is the path of least resistance. However, the shutdown's duration is indeterminate. Budgetary negotiations have reached an impasse. The federal government has been non-operational for more than 1 month. Essential personnel are continuing their work without remuneration. Non-essential employees have been placed on temporary leave. NASA is currently functioning under emergency protocols. Certain missions are facing potential jeopardies. The International Space Station remains unaffected. Deep space exploration endeavors are proceeding as planned. However, research programs have been suspended. The planetary data system is updating its archives on a reduced operational schedule. The release of new data has been postponed. 3i Atlas has become ensnared in this predicament. What incenses me is this: we have a singular opportunity. 3i Atlas represents an object of a lifetime. It is merely the third interstellar visitor humanity has ever detected. It is the first encountered early enough for us to observe its complete trajectory as it approached the sun. We possess spacecraft orbiting Mars. We have probes positioned in proximity to the sun. We have the James Webb Space Telescope, the Hubble Space Telescope, and the most sophisticated astronomical instruments ever conceived by humankind, all presently directed towards this celestial entity. And the data pertaining to it is being obstructed by political considerations concerning the budget, by a governmental body incapable of reaching a consensus on fiscal priorities, and by a system that regards scientific discovery as an optional pursuit, something that can be deferred until the deliberations among those in leadership positions are concluded. Loeb has been vociferously advocating for this release because someone must. The broader astronomical community adopts a more circumspect approach. They publish meticulously researched papers. They articulate their concerns diplomatically. They are unwilling to alienate NASA, as their research is contingent upon NASA's funding. Loeb, however, is unconcerned. He holds a tenured position at Harvard. He benefits from independent financial backing through the Galileo Project. He possesses the financial latitude to disregard established relationships, and he is leveraging this position to demand what should not require such insistence. Release the data, show us what you have observed, allow the scientific community the opportunity to scrutinize it, engage in discourse regarding its implications, ascertain its true meaning. His appearance on the Joe Rogan Show amplified this message to an audience numbering in the millions. Rogan's listeners do not constitute the academic astronomical community. Rather, they represent the general populace. These are individuals with a keen interest in space, extraterrestrial life, and unresolved mysteries. Loeb purposefully chose to appear on that program, aware of his capacity to reach these individuals, knowing the message would disseminate widely, and anticipating it would exert pressure on NASA in ways that scholarly publications cannot achieve. This strategy has proven effective. The narrative has now permeated mainstream discourse. Prominent news organizations are providing coverage. Congresswoman Luna has intervened. The high-resolution imagery data has transitioned from a purely scientific matter to a public concern. Nevertheless, the images themselves remain unavailable, and with each passing day, the context surrounding their significance diminishes. 3i Atlas is continuing its outward trajectory from Mars. It is advancing towards the point where it will again be observable from Earth. When this occurs, and telescopes commence the collection of new observations, the data gathered from Mars will become historical in nature. While still important, its urgency will wane. The opportune moment is receding, and the window during which those images could provide definitive insights, potentially corroborating or refuting the artificial hypothesis, is closing. A broader perspective is warranted concerning our approach to anomalous data. When an observation deviates from our expectations or challenges our established models, our inherent inclination is to exercise caution, to conduct rigorous double checks, and to await verification. This is a hallmark of sound scientific practice. However, it can also lead to stagnation. If every unusual finding necessitates extensive vetting, formal approval, and sanitization, prior to its release, we compromise the rapid iterative process that drives scientific progress. We forfeit the capacity for independent researchers to examine raw data and identify phenomena overlooked by the originating team. We sacrifice transparency. The high-resolution images might depict a commonplace comet. They might reveal something intriguing, yet readily explainable. Or they might unveil information that compels us to fundamentally reevaluate our current understanding of the universe. We will remain uninformed until NASA makes them publicly accessible. And NASA will not release them until the government shutdown concludes, or until an authorized individual determines the matter to be of sufficient importance to supersede standard protocols. Loeb and Luna are actively working towards this objective. The outcome hinges on the degree of seriousness with which the acting administrator regards this issue, and whether he possesses the capacity to address it amidst the agency's crisis state. In the interim, 3i Atlas continues its celestial journey at a velocity of 68 kilometers per second, carrying whatever undisclosed secrets it may hold. The most comprehensive images we possess are presently confined to a server. The scientist most eager for their release is featured on podcasts and contributes to blog posts. A congresswoman is composing formal letters, and the remainder of us are in a state of anticipation, hoping that the bureaucratic machinery operates with greater alacrity than an interstellar object, while recognizing that this is unlikely to occur. The connection to the WOW signal, a transmission originating in 1977. On the 15th day of August in 1977, the Big Ear radio telescope at Ohio State University detected a phenomenon that defied conventional expectations. A powerful, narrow-band radio signal operating at a frequency of 1,420 megahertz, precisely the hydrogen line. This frequency is meticulously monitored by all radio astronomers due to hydrogen's status as the most abundant element in the cosmos. Consequently, any civilization endeavoring to transmit signals across interstellar distances might conceivably utilize it. The signal persisted for 72 seconds, corresponding exactly to the observation duration of the Big Ear telescope for any given celestial region. Its intensity and unexpected nature prompted astronomer Jerry Eman to inscribe the word "wow" in red ink on the computer printout. This designation subsequently became permanently associated with the signal. Despite decades of diligent searching and numerous attempts to redetect it, the signal has never reappeared. It manifested as a single burst, lasting 72 seconds, followed by an enduring silence. 3I Atlas originated from a celestial direction within a 9-degree proximity to this event. Avi Loeb calculated this correlation 2 months ago, publishing his analysis in September. The WOW signal emanated from a region of the sky designated by a right ascension of 19 hours, 25 minutes, and a declination of minus 27 degrees on August 12, 1977, precisely 3 days prior to the signal's detection. At that time, 3I Atlas was situated at a right ascension of 19 hours, 40 minutes, and a declination of minus 19 degrees, representing a 4-degree variance in right ascension and an 8-degree variance in declination, resulting in a total angular separation of approximately 9 degrees. The statistical probability of two independent celestial directions aligning to such a degree by random chance is estimated at 0.6%. Let us contemplate the implications of this finding. The WOW signal was initially detected in 1977. During that period, 3I Atlas was situated at an approximate distance of 600 astronomical units from Earth, equivalent to 600 times the distance between the Earth and the Sun. The light travel time from this object would have been approximately 3 days. The signal, originating from its source, reached Earth on August 15th. If it indeed originated from 3I Atlas, it would have departed the object on August 12th. The temporal alignment is consistent, as is the geometric configuration and the signal frequency. Now, a primary objection raised is that we do not possess definitive knowledge that the WOW signal originated precisely from 19 hours, 25 minutes, and 27 degrees. Our understanding is limited to the general vicinity of the sky from which it was received. The observational beam of the Big Ear telescope was relatively broad, spanning several degrees. Consequently, the precise point of origin could have been anywhere within that illuminated area. While this degree of uncertainty is acknowledged, a 9-degree deviation falls well within the telescope's beam width, meaning 3I Atlas would have been within its field of observation. If an entity were to transmit a signal from 3I Atlas towards Earth with the intention of its detection, it would naturally be aimed in that direction, and the signal would subsequently arrive from that perceived origin. The selected frequency is particularly noteworthy. The frequency of 1,420 MHz is not arbitrary. It corresponds to the hyperfine transition of neutral hydrogen. When the electron within a hydrogen atom alters its spin relative to the proton, it either emits or absorbs a photon at this specific frequency. This is commonly referred to as the 21 centimeter line, a spectral signature that radio astronomers utilize to map the distribution of hydrogen throughout the galaxy. It is also a frequency that SETI, Search for Extraterrestrial Intelligence, initiatives prioritize, as any technologically advanced civilization would be aware of its significance. To transmit a signal that would be unmistakably recognized as artificial and distinct from natural cosmic background radiation, one would select a frequency imbued with meaning. 1,420 MHz communicates a message. We possess an understanding of fundamental physics and astronomy. This transmission is intentional. The WOW signal was remarkably strong. Its intensity registered 30 times above the ambient noise level. For comparative purposes, typical cosmic radio sources detected by the Big Ear telescope usually registered only 2 or 3 times above the background noise. An intensity 30 times greater is exceptionally significant. This suggests either an extremely powerful transmitter or a transmitter located in relatively close proximity to the observer. Loeb calculated the requisite power output for the signal to have originated from 3I Atlas at a distance of 600 astronomical units, approximately 1 gigawatt. This is comparable to the power output of a nuclear power plant, a level that is not considered unreasonable for a technologically sophisticated civilization, and certainly within the capabilities of a species capable of constructing interstellar spacecraft. However, a significant impediment exists. The signal was never repeated. Astronomers have scanned that particular region of the sky hundreds of times since 1977, employing diverse telescopes, frequencies, and observational strategies. No subsequent signal has been detected. The Big Ear telescope itself reobserved the same celestial point on multiple occasions, yielding only silence. Whatever phenomenon generated the wow signal was either a singular event or an exceedingly rare occurrence, and it has eluded detection for nearly 5 decades. If 3i Atlas was indeed the source of the wow signal, the question arises, why transmit a solitary burst in 1977 and then cease all transmissions? One plausible explanation is that it served as a test, an interstellar probe activating its transmitter to verify its functionality, to announce its presence, and subsequently powering down to conserve energy for its extensive journey. In 1977, 3i Atlas was still positioned far from the Sun, dwelling in the frigid expanse of interstellar space, and not yet observable by optical telescopes. If the intention was to signal ahead and notify potential recipients of its impending arrival, it would be logical to do so early in its trajectory, prior to its primary mission phase and perihelion passage. This would involve transmitting a brief signal, awaiting any acknowledgement, and then continuing its course. Another possibility is that the transmission was not directed towards Earth. It is conceivable that 3i Atlas was engaged in communication with another entity, perhaps another probe, a communication relay station, or even its originating homeworld. We lack this knowledge. It is possible that we fortuitously intercepted a signal intended for another recipient or object. If this were the case, we would not anticipate its repetition in the direction of Earth, as it was never intended for our reception. We were merely incidental listeners. Alternatively, it is possible the signal was indeed directed towards us. In the absence of repetition signifies that we failed a critical test. We detected it, acknowledged its presence by noting "wow" on a printout, and subsequently took no further action. We did not reciprocate with a response, nor did we initiate a coordinated search effort, nor did we treat it with the seriousness it perhaps warranted. The Big Ear telescope was dismantled in the 1990s to accommodate the construction of a golf course. The site no longer exists. If an extraterrestrial intelligence sought to ascertain humanity's attentiveness, its capacity to detect and respond to interstellar signals, the wow signal would have indicated our inadequacy in this regard. Our detection was rudimentary, and our subsequent inaction led to its fading into historical obscurity. The 0.6% probability, while statistically low, is not entirely negligible. If one were to conduct a similar analysis for every object within the solar system, cross-referencing their trajectories with historical astronomical events, coincidences would inevitably emerge. The vastness of the sky contains a multitude of objects and occurrences, and some alignments will inevitably arise purely by chance. However, 3i Atlas is not an ordinary celestial object. It already exhibits anomalous characteristics in 8 distinct aspects. The correlation with the wow signal represents the 9th such coincidence, superimposed upon the others. At what juncture does one cease to categorize these occurrences as mere coincidences? Loeb articulated a broader implication in his analysis. We actively transmit signals into the cosmos. Examples include the Arecibo message in 1974 and the Voyager Golden Records. Furthermore, we continuously broadcast radio and television signals in all directions on a daily basis. We operate under the assumption that if extraterrestrial civilizations exist, they might be observing, might detect our transmissions, and might respond. However, we also presume that if an extraterrestrial civilization transmits a signal towards us, we will recognize it, treat it with due consideration, and take appropriate action. The wow signal precisely matched the characteristics sought by SETI initiatives, a powerful, narrow band transmission at a significant frequency, originating from beyond our solar system. Despite this, our follow-up actions were inadequate. We did not develop more sophisticated telescopes to investigate that specific region of the sky. We did not mobilize coordinated international efforts for continuous monitoring. We published academic papers discussing it, engaged in debates regarding its potential nature, and ultimately allowed it to recede into historical annals. If that signal constituted a deliberate message, we effectively ignored it. Now, approximately 50 years later, the celestial body that may have transmitted it is traversing our solar system. It passed Mars in October and is progressing towards its closest approach to Earth in December. Yet, we are engaged in debates regarding its classification as a mere comet. Perhaps the WOW signal served as a preliminary announcement. Perhaps 3i Atlas represents a subsequent communication. It is conceivable that we are being afforded a second opportunity, which we are once again squandering by focusing on bureaucratic impediments and academic rivalries, instead of coordinating all available telescopic resources to definitively ascertain the true nature of this object. Radio astronomers are presently engaged in monitoring 3i Atlas. Following Loeb's publication of the WOW signal correlation, several research groups discreetly initiated observational campaigns. They are actively searching for transmissions at 1,420 MHz and other frequencies, scrutinizing for pulse signals, modulation patterns, or any indicator suggestive of active communication. To date, no public announcements have been made, but radio observations are inherently complex. The object is faint, it is moving at high velocity, and it necessitates extended integration periods to detect subtle signals. Moreover, if 3i Atlas is deliberately maintaining silence, having transmitted once in 1977 and now operating in a passive mode, we will not receive any further transmissions until it chooses to communicate again. Additionally, there's the question of whether we should respond. If 3i Atlas is indeed a probe, systematically gathering information about our solar system, Earth, and its inhabitants, should we attempt to establish communication? SETI protocols advocate for a positive response. If its artificial nature is confirmed, the Rio scale, which quantifies the significance of potential extraterrestrial detections, would categorize confirmed alien technology within our solar system at the highest echelon. This would represent humanity's most momentous encounter, first contact. Our response should be characterized by meticulous consideration and thoughtful deliberation, with messages crafted to convey peaceful intentions and fundamental information about our species. Conversely, some argue for a cautious approach, stating, "We are uncertain of its intentions. We do not know what 3i Atlas is specifically seeking, nor what it might do with information pertaining to us. We cannot ascertain whether the civilization that dispatched it is benevolent, indifferent, or hostile. If it has been present for months, observing silently, perhaps the most prudent course of action is to reciprocate with silent observation. Gather what information we can without revealing more than necessary. Maintain a posture of vigilance. The dark forest hypothesis, which posits that the universe is replete with civilizations deliberately concealing themselves from one another, due to the inherent risk of being targeted by the first entity to reveal its presence, would strongly support a strategy of silence. The advice is to refrain from provocation, to avoid engagement, and to remain hidden. The correct course of action remains unclear. However, it is evident that this profound issue is not being addressed with the gravity it deserves. The correlation with the WOW signal should be headline news, prompting emergency funding for observational efforts, analytical studies, and coordinated international initiatives. Instead, it is relegated to a footnote in Avi Loeb's blog posts, a mere curiosity mentioned in interviews, and a statistical anomaly that the majority of astronomers dismiss without serious contemplation. The signal originated from the correct celestial direction. The object originates from the same celestial direction, separated by a 50-year interval, with a mere 0.6% probability of random alignment. And now, the object is present within our solar system, exhibiting behaviors inconsistent with those of typical comets. Yet we persist in the pretense that there is no connection. Perhaps there is no connection. It is possible that all of this is mere coincidence, an improbable chemical reaction, or natural processes that we have yet to fully comprehend. However, if we are mistaken, if the WOW signal represented 3i Atlas extending a greeting, and we disregarded it, and it is now present and we continue to ignore it, history will judge us harshly. We will be remembered as the generation that experienced first contact but failed to recognize it because we were preoccupied with debating whether it conformed to our preconceived models. 9 anomalies and a probability of 1 in 10 quadrillion. Let us consolidate all the available evidence. We have 9 distinct anomalies, 9 separate observations that individually deviate from our expectations for a naturally occurring interstellar comet. Avi Loeb meticulously maintains a record, updating it as new data becomes accessible and calculating the probability associated with each observation. When these probabilities are multiplied, reflecting the likelihood of all 9 anomalies occurring simultaneously within the same object purely by chance, the resulting number becomes so infinitesimally small that it loses its quantifiable meaning, 1 in 10 quadrillion, or 1 in 10 to the 16th power. For perspective, the Milky Way galaxy contains approximately 100 billion stars. A probability of 1 in 10 quadrillion is 100,000 times less likely than selecting a single specific star at random from the entirety of the galaxy. Let us examine each anomaly individually. This is not to reiterate details already covered extensively, but rather to discern the emerging pattern and understand why the significance lies not in any single anomaly, but in the collective body of evidence, the totality of observations, and the cumulative weight of the data that consistently points in the same direction. Anomaly 1. The trajectory is aligned within 5 degrees of the ecliptic plane, the orbital path of the planets around the Sun. Objects traveling through interstellar space typically follow random trajectories, lacking any correlation with the structural orientation of specific solar systems. The probability of an interstellar object's trajectory coincidentally aligning with our planetary plane is approximately 0.2%. While not impossible, it is an infrequent occurrence. Now, if an object were designed as a probe, intended to survey a solar system and pass in close proximity to multiple planets, its trajectory would undoubtedly be aligned with the ecliptic. This is precisely where the planets reside, where moons orbit, and where the potential for life exists. Random comets exhibit no regard for our planets. Probes, however, do. Anomaly 2. The anti-tail. From July through August, 3i Atlas exhibited a jet of material projecting towards the Sun. We have previously discussed this phenomenon. Anti-tails can sometimes be optical illusions. However, this particular instance is demonstrably not an illusion. Multiple viewing angles and numerous observations unequivocally confirm its reality. Actual material is being propelled sunward. Comets do not naturally exhibit this behavior because the pressure exerted by solar radiation typically repels material away from the Sun. Apparent anti-tails can arise from geometrical configurations involving dust particles in specific orbital arrangements. But these are not genuine jets. The only natural mechanism capable of producing a genuine sunward jet involves a highly specific rotational pattern and outgassing geometry. Alternatively, this could represent exhaust from a propulsion system, indicative of course corrections being made. The third peculiarity is its dimensions. This celestial body possesses a central mass at least 5 kilometers across, perhaps even larger, leading to an estimated total weight of at least 33 billion tons. This dwarfs Oumuamua, our first detected interstellar visitor, by a factor of 1 million and is 1,000 times more substantial than Borisov. Typically, cosmic wanderers should adhere to a predictable size hierarchy, with smaller entities being significantly more prevalent than their colossal counterparts, much like the asteroids and comets populating our own solar system. Yet we have now encountered 3 such interlopers. The initial one was minuscule, the second of moderate size, and this third one is colossal. The likelihood of encountering such a monumental object, given the expected cosmic population distribution, is exceedingly remote. If the third visitor, designated 3i Atlas, is indeed artificial, a manufactured construct, its size would not be constrained by the usual physical processes of cosmic aggregation. Instead, it could be constructed to whatever scale is required: a colossal carrier vessel, a generational ark, or a mobile outpost. Such creations would naturally be immense, far exceeding the dimensions of typical comets. The fourth anomaly concerns the precise timing and configuration of its trajectory. 3i Atlas reaches its closest point to the Sun, its perihelion, on October 29th. At this specific juncture, it is obscured from Earth's view, positioned directly behind our Sun. However, it passes within tens of millions of kilometers of Mars, Venus, and Jupiter. Its path is meticulously calibrated for close encounters with multiple planets, while maintaining invisibility to terrestrial telescopes during its most crucial phase. According to calculations by astronomer Avi Loeb, the probability of such a specific geometric alignment occurring by sheer chance is a mere 0.005%. If one intended to conduct a survey of the inner solar system, passing in close proximity to several worlds without revealing their presence to the dominant intelligent civilization, this trajectory would be the perfect blueprint. The fifth anomaly lies in its nickel to iron ratio. We have extensively examined this aspect. It exhibits nickel emissions without a corresponding increase in iron. Specifically, 4 grams per second of nickel are detected, a quantity orders of magnitude greater than the nickel to cyanide ratio found in any known comet. The natural occurrence of such a ratio is less than 1% probable. This suggests industrial chemistry, manufactured materials, or an exceptionally peculiar natural chemical process that remains entirely unknown and difficult to explain. The sixth anomaly pertains to its water content, which constitutes 4% of its total mass. Standard comets, in contrast, are composed of 50 to 80% water. 3I Atlas is predominantly characterized by carbon dioxide and carbon monoxide. By natural cometary standards, this makes it a poor candidate, but from an engineering perspective, it functions as an efficient spacecraft. This composition means less mass to transport and potentially superior propulsion characteristics. The probability of this occurring naturally is less than 1%. The seventh anomaly is its extreme negative polarization. When light reflects off a surface, it becomes polarized. The degree and direction of this polarization provide insights into the surface properties, the size distribution of particles, and the overall composition. 3I Atlas displays an exceptionally negative polarization, exceeding that of any previously observed comet, including Borisov. This phenomenon indicates surface or particle characteristics that are entirely unprecedented. The probability of this occurring naturally is less than 1%. While unusual, its implications are uncertain. Does it point to metallic surfaces, engineered materials, or simply an unconventional configuration of ice and dust that current models fail to capture? The eighth anomaly relates to the alignment with the WOW signal, occurring with a probability of 0.6%. 50 years ago, a signal was detected. Now, an object originating from the same direction appears. Could this be a coincidence, a message accompanied by its messenger? The ninth anomaly, the most recent addition to the list, noted less than a week ago, involves its striking blue hue and its rapid brightening as it approaches perihelion. Its color is bluer than that of our sun, and its accelerated brightening surpasses that of any known comet. This behavior is inconsistent with thermal radiation from a frigid object and necessitates either intense gas expulsion or an alternative energy source. This ninth anomaly, the newest peculiar characteristic, emerged from observations made while the object was behind the sun. In total, there are 9 anomalies. Each possesses an associated probability, and each is unlikely, though not impossible. When these probabilities are multiplied together, the resulting likelihood is 1 in 10 quadrillion. Avi Loeb posits that this number is so infinitesimally small, so far beyond the realm of plausible chance, that we are compelled to seriously entertain an alternative explanation, not as a definitive conclusion, but as a hypothesis worthy of rigorous testing. This hypothesis suggests that 3I Atlas is not a natural phenomenon, but rather a technological artifact. It proposes that these anomalies are not isolated coincidences, but rather interconnected features of a deliberately designed object. The counterargument, however, is that these probabilities are not independent. If 3I Atlas originated in an atypical environment, if it accreted from materials with unusual chemical compositions, then that chemistry would likely influence multiple of its properties. The nickel content, the water fraction, the polarization, and possibly even its outgassing behavior could all stem from a single, unconventional formation scenario. Consequently, one should not simply multiply the probabilities as if they were independent events. The coincidences are intrinsically linked. Understanding the formation environment, it is argued, might unify all these anomalies. This is a valid point. However, What specific formation environment could simultaneously account for nickel in the absence of iron, trajectories aligned with the ecliptic plane, and the emission of signals reminiscent of the wow signal? At a certain point, the hypothesis that seeks to explain everything requires more assumptions than the hypothesis that explains a single phenomenon. Occam's razor is intended to favor simpler explanations, yet simplicity is not merely about enumerating hypotheses, but about counting the underlying assumptions. The natural comet hypothesis necessitates assuming unusual chemistry, an unusual trajectory, unusual timing, unusual composition, unusual emissions, and unusual everything. In contrast, the artificial object hypothesis relies on a single assumption: intelligence. And as far as we are aware, intelligence demonstrably exists. We are living proof. The fundamental questions then become whether intelligence exists beyond Earth, and whether it constructs artifacts, and whether one such artifact is currently traversing our solar system. Avi Loeb has developed a scale for this purpose, the Loeb scale, ranging from 0 to 10. A score of 0 signifies a definitively natural object, while a 10 indicates a definitively artificial one. He places 3i Atlas at a score of 4. This indicates an uncertain midpoint. It exhibits more anomalies than one would expect from a natural object, yet it lacks the definitive smoking gun evidence required for absolute proof. A score of 4 suggests that the phenomenon warrants serious consideration and thorough investigation. It is not a call to raise an immediate alarm, proclaiming that aliens have arrived. Rather, it signifies that something is profoundly unusual, poorly understood, and necessitates the application of every available tool for its elucidation. The challenge lies in the fact that thorough investigation demands resources, coordinated efforts, and institutional backing. It requires NASA to release its data, observatories to dedicate telescope time, and funding agencies to regard the artificial hypothesis with sufficient seriousness to support proposals that explore it. Currently, this is not happening. This is not due to any conspiracy, but rather because the scientific community is inherently conservative. Anomalies are frequently erroneous. Equipment malfunctions, calibration errors, and misinterpretations are far more common than paradigm shifts. Every researcher has experienced the sting of a false alarm, of claims that ultimately proved unfounded. Countless instances have arisen where something appeared artificial, only to be revealed as natural. But what about 1 in 10 quadrillion? At what probability threshold does one revise their prior beliefs? At what point does the accumulation of improbable events compel consideration of an improbable explanation? If 3i Atlas had exhibited 2 anomalies, it would be understandable. With 3, it might be considered a peculiar comet. 4, 5, 6, 7 anomalies. These numbers make it increasingly difficult to ignore. By anomaly 8, we are obligated to engage in a serious discussion about what we are truly observing, a conversation that is not currently happening at the necessary level. While some are discussing it vociferously on podcasts and blogs, and a few other researchers are quietly performing calculations, verifying numbers, and writing meticulous papers that hint at possibilities without committing to firm conclusions, the broader scientific community remains largely dismissive or silent. Dismissal stems from disbelief in the validity of the anomalies, the conviction that natural explanations are sufficient, or a reluctance to be associated with the extraterrestrial hypothesis. Silence arises from uncertainty about how to respond, a waiting game for more data, or institutional incentives that discourage speculation. The figure of 1 in 10 quadrillion will undoubtedly face scrutiny. Debates will erupt concerning the probability calculations, the assumptions of independence, and whether the anomalies are indeed as improbable as Loeb suggests. These discussions are valuable. Scientific progress thrives on critique, on peer review, and on the demand for rigor. However, such critiques must be substantive, offering alternative explanations that genuinely align with the observed data. Merely stating that something is likely natural because most things are natural is not an explanation. It is a default assumption. And default assumptions are maintained until compelling evidence necessitates their revision. We possess evidence, 9 distinct pieces, each pointing in the same direction. December promises additional data. 3i Atlas will become visible from Earth, fully observable, no longer obscured by the sun. Spectroscopic analysis will reveal whether the chemical signatures remain consistent. Photometry will determine if the observed brightness variations are compatible with a natural object. Astrometry will ascertain if the acceleration persists, if the trajectory continues to exhibit self-correction, and if the object behaves as if it possesses agency over its movement. Furthermore, we will observe if the anomalies increase, if we reach 10, 11, or 12. At some point, even the most reticent scientist will be compelled to acknowledge that the artificial hypothesis is no longer a fringe notion but the sole plausible explanation, or conversely, that the anomalies will be resolved. We will discover natural explanations that prove sufficient. The chemistry will make sense, the trajectory will stabilize, and the mystery will resolve into a lack of understanding rather than the presence of intelligence. In such a scenario, we will gain valuable insights into comets, interstellar objects, and the sheer diversity of phenomena that can arise in the universe. This would represent a positive outcome as science advances regardless. However, if the situation unfolds in the opposite direction, if the observations in December corroborate the indications from October, we will enter uncharted territory, not just scientifically, but culturally, philosophically, and existentially. The figure of 1 in 10 quadrillion might well become the statistic that irrevocably alters everything. Planetary defense protocols were activated in response to an interstellar visitor. On October 21st, the International Asteroid Warning Network, IAWN, issued a formal notice through the Minor Planet Center, adding 3I Atlas to its observation campaign. This marks the first instance in history where IAWN has specifically targeted an interstellar object. Established in 2014 under the auspices of the United Nations, this network is tasked with detecting, monitoring, and characterizing potentially hazardous asteroids and near-Earth objects with the primary mandate of planetary defense. Its objective is to provide early warnings of any collision course with Earth, furnish data for mitigation strategies, and facilitate international response coordination. Crucially, 3I Atlas poses no threat of collision with Earth. Both NASA and the European Space Agency, ESA, have confirmed it will not approach within 1.8 astronomical units, approximately 270 million kilometers, of our planet. So why did IAWN initiate its tracking campaign? The official rationale states that comets present unique challenges for astrometry and orbit prediction. The notice explicitly mentions that cometary bodies are diffuse, possessing comas and tails, and these morphological features can displace the perceived center of mass from the actual nucleus. This ambiguity complicates precise location determination, making accurate future trajectory predictions difficult. For an object moving at the high velocity of 3I Atlas, even minor inaccuracies in positional measurements can rapidly compound. IAWN requires precise tracking, necessitating observations from multiple locations and instruments to refine orbital elements and reduce uncertainty. This is standard procedure for comets that could potentially pose a future threat. Even if the current trajectory is deemed safe, the imperative is to gather data, improve predictive models, and build institutional knowledge for future scenarios. However, 3I Atlas is not a near-Earth object in the conventional sense. It is not on a trajectory that would bring it into proximity with Earth now, nor in the foreseeable future. It is following a hyperbolic path originating from interstellar space, passing through our solar system, and continuing its outward journey. It is a one-time event. The threat it presents, if any, is not kinetic. It does not involve impact energy, potential tsunamis, or extinction-level events caused by a celestial body striking the planet. The threat, if we are to take Avi Loeb's perspective seriously, lies in our lack of knowledge regarding its nature, its purpose for being here, and its potential future actions. IOWN's inclusion of 3I Atlas in its campaign signifies a subtle but definite acknowledgement that this object warrants monitoring, not due to a potential impact, but because it might represent something entirely different. The timing of the IAWN notice is significant. October 21st marks the date of solar conjunction, when 3I Atlas moved directly behind the Sun from Earth's vantage point, representing the peak of the observational blackout period. IAWN issued its notice precisely at the moment when Earth-based telescopes, could no longer observe the object, rendering us effectively blind, during which any events occurring at Perihelion would transpire unseen. Was this merely routine bureaucratic timing, or was it a deliberate signal, a way of communicating, without explicit declaration, that certain individuals within the planetary defense community are taking the observed anomalies with sufficient seriousness to formalize a response? The campaign is officially described as a training exercise. IAWN utilizes real celestial targets to practice coordination, test communication protocols, and refine observation strategies. This makes logical sense. Planetary defense is a critical capability that should not be developed during an actual emergency. Practice drills, scenario simulations, and identification of procedural bottlenecks are essential to ensure preparedness when stakes are low. 3i Atlas serves as a suitable training target. It is fast, challenging to observe, and necessitates international cooperation. It rigorously tests the ability to track an unusual object under demanding conditions. These are all valid justifications for its selection. However, it also functions as a cover. If IAWN harbors even a remote suspicion, any non-zero probability, that 3i Atlas might be artificial, that it could potentially maneuver, deploy smaller probes, or engage in other unforeseen actions, they cannot publicly disclose such concerns. Doing so would risk inciting panic, inviting ridicule, and generating a media frenzy that would impede rational analysis. Consequently, they cite training exercise, astrometric challenges for comets, and standard procedure. Behind this facade, they quietly allocate resources, orchestrate observations, and maintain vigilant watch. The campaign is scheduled to run from late November 2025 through January 2026, a 2-month period encompassing the time when 3i Atlas will be most observable from Earth, within close enough proximity for detailed scrutiny, and when any anomalous behavior would be most apparent. If the object is indeed capable of purposeful action, if it intends to alter its course or release any subordinate components, these events are most likely to occur within this time frame. IOWN will be observing intently. Multiple observatories, a variety of instruments, synchronized timing, all contributing data to a central analytical system. If 3i Atlas deviates from its predicted trajectory by even a slight margin, they will detect it. There is precedent for such discrete alerts. Consider the Oumuamua situation in 2017. Upon its discovery and the subsequent calculation of its trajectory, its interstellar origin became clear, prompting a brief period of intense scientific interest. Subsequently, as it moved beyond the range of telescopic observation, the discourse shifted towards speculation. Avi Loeb championed the possibility of it being artificial, while the mainstream scientific community favored natural explanations, leaning towards it being an asteroid, or perhaps a comet with unusual characteristics. No definitive consensus was reached. However, during the observational window when Oumuamua was trackable, considerable behind-the-scenes coordination took place. Observatories shared data, governments received briefings, and SETI researchers were consulted. None of this was publicly announced. There were no press releases or formal statements. It was simply professionals diligently performing their duties, covering all bases to ensure that any unexpected eventuality would be noticed. 3i Atlas is receiving similar treatment, albeit in a more formalized manner. The IAWN campaign elevates this oversight to an official status, establishing a framework for data dissemination, coordinated responses, and potential escalation protocols. Escalation to what, one might ask? If 3i Atlas is definitively confirmed as artificial, what would be the established protocol? Who would be responsible for decision-making? Who would represent humanity? These critical questions remain unanswered and, indeed, are not even publicly addressed. Nevertheless, somewhere within the relevant institutions, these considerations are being contemplated. Someone likely possesses a checklist, a chain of command, and a set of talking points for a press conference that, hopefully, will never be necessary. The involvement of the United Nations is particularly noteworthy. IAWN operates under UN frameworks. While not a binding authority, its framework provides international legitimacy, as countries participate voluntarily. Should the situation escalate and 3i Atlas be confirmed as a contact scenario, The UN infrastructure is already in place. There exists a committee on the peaceful uses of outer space, a treaty framework governing space activities, and established mechanisms for international dialogue. By activating IAWN for 3I Atlas, the object is brought within this established framework, creating a documented record and asserting a degree of jurisdiction. It is important to note that the majority of astronomers participating in the IAWN campaign likely believe this is a routine matter concerning comets, astrometry, and training. They are not anticipating the imminent arrival of an alien mothership. They are engaged in the practice of science, collecting data, refining models, and publishing research. However, the individuals who authorized the activation of the campaign, the administrators and policymakers who approved it, are aware of the broader context. They are cognizant of Avi Loeb's analysis and the reported anomalies. They understand that this object is not ordinary. Even if the officially stated reason is routine, planetary defense extends beyond merely tracking potentially impacting rocks. It encompasses existential threats. The discovery of extraterrestrial intelligence would constitute an existential threat, not necessarily in terms of immediate danger, but in terms of profound disruption. Everything would change: our understanding of our place in the cosmos, our conception of life, our political and economic systems, our religions, our philosophies, all would suddenly be contingent upon our relationship with this new intelligence. Planetary defense inherently includes preparation for such scenarios. This preparation is not conducted publicly, as doing so would risk creating the very disruption it seeks to manage. Instead, it occurs discreetly, behind closed doors, within contingency plans stored securely, and discussed only in classified briefings. IAWN's targeting of 3I Atlas is a data point, not definitive proof. It does not unequivocally signify that those in charge believe it to be alien technology, but it does indicate that they are not dismissing that possibility. It signifies a degree of caution, which in this context is entirely rational. If there exists even a 1% probability that 3I Atlas is artificial, the implications are so profound that treating it with utmost seriousness is the only responsible course of action. One does not wait for absolute certainty. One acts upon possibility, gathers data, coordinates resources, and prepares for contingencies. This is precisely the function of planetary defense. The campaign will yield a substantial volume of data, including astrometric, photometric, and spectroscopic information, all of which will be archived and accessible to researchers. If 3I Atlas behaves as a natural comet, the data will confirm this. The models will align, the orbit will conform to gravitational predictions, with minor adjustments for outgassing, and its brightness will diminish as anticipated. The chemical signatures will be consistent with the sublimation of volatile compounds. In such an event, IAWN will conclude the campaign as a successful training exercise, noting lessons learned and procedures refined, with commendations for all involved. However, if the data reveals something different, if the orbit deviates in ways inexplicable by outgassing, if the object accelerates, decelerates, or changes direction without apparent cause, or if new, unexpected features emerge, IAWN will escalate its response. The campaign will transition from a training exercise to an actual operational response, and the protocols that have been maintained in readiness for a scenario everyone hoped would never materialize will be activated. We find ourselves in a peculiar juncture. 3I Atlas represents simultaneously the third interstellar comet ever observed and potentially the most significant object humanity has ever encountered. It is perceived as routine enough for a training exercise, yet significant enough to warrant international coordination. This object presents itself as both a scientific enigma and a harbinger of a significant conceptual shift. Its inherent vagueness is a deliberate strategy, facilitating preparedness without immediate commitment, enabling vigilance without sparking panic, and allowing observation without triggering undue alarm. However, this uncertainty is not destined to persist indefinitely. Either the celestial body designated as 3IA is a naturally occurring phenomenon, in which case we shall proceed without further disruption, or it is not, signifying a fundamental alteration to our understanding of reality. In either eventuality, Jan is ensuring our readiness. The strategy under consideration is multifaceted, encompassing theories like the Trojan horse maneuver, the deployment of miniature probes in scenarios involving a mothership. Perihelion represents the most advantageous juncture for a spacecraft to dispatch observational devices. At this point, a vessel is deeply immersed within a gravitational field, moving at considerable velocity, and any imparted momentum to a smaller object is amplified by the principles of orbital mechanics. Should the objective be to direct something towards the inner planets, Earth, Venus, or Mars, for instance, it would be released at perihelion with a subtle impetus, with the sun's gravitational influence completing the trajectory. This approach is characterized by its mathematical elegance and operational efficiency. 3IA achieved its perihelion on October 29th, positioned behind the sun, rendering it undetectable from Earth at the precise moment optimal for such a deployment. Avi Loeb labels this the Trojan horse scenario, an entity that superficially resembles a natural comet, eliciting no suspicion from afar, yet concealing within it secondary craft, instruments, or probes designated for specific investigative tasks. The primary vessel, or mothership, traverses the solar system on its hyperbolic path, a singular, non-repeatable passage, never to return. The probes, however, are designed to remain. They establish orbits around the sun or individual planets, assuming positions conducive to observation, data acquisition, and the transmission of findings back to the mothership's ultimate destination, or to the originating intelligence. By the time the full implications are grasped, the mothership will have long departed, and the probes will be integrated into our celestial neighborhood. These probes, too small for easy detection and too numerous for individual tracking, represent a significant challenge. This is not a flight of fantasy, it is a pragmatic mission design for the exploration of distant star systems. The rationale is that decelerating an entire mothership expends excessive energy and time. Instead, the vessel proceeds at high speed, conducting initial observations during its transit and subsequently deploying instruments for sustained study. This concept is not entirely alien to us. While we have yet to embark on interstellar missions of this nature, the underlying principle is familiar. Consider the Voyager probes, or the New Horizons flyby of Pluto, rapid passes, data collection, and onward movement. To thoroughly investigate an entire solar system, multiple vantage points are indispensable, necessitating long-term monitoring instruments situated at various locations. A single large object cannot fulfill this requirement. However, a multitude of smaller objects can. The object's retrograde trajectory further facilitates this objective. 3IA is traversing space in opposition to the direction of planetary orbits. Retrograde orbits are exceptionally well suited for reconnaissance missions, as they provide repeated opportunities for encounters with planets as they complete their orbital cycles. Releasing a probe with a minor adjustment in velocity causes it to enter an elliptical retrograde orbit, eventually crossing the paths of all the inner planets over time, thus allowing a single probe to target multiple celestial bodies. If several probes were deployed with subtly different orbital parameters, the inner solar system could be comprehensively surveyed, ensuring continuous observation. The critical question remains, would we detect the release? If 3IA ejected a smaller object during its perihelion passage, would our instruments register such an event? It is highly probable that they would not. The object was obscured by the sun, observable only by chronographs that were already struggling to track the primary body. A diminutive probe, even one several meters in diameter, would fall below the detection threshold, remaining invisible in the imagery. Its presence would only become apparent once it had sufficiently distanced itself from the parent body to be resolved as a distinct entity. At that juncture, the connection might no longer be immediately obvious. One might observe a new, small comet or asteroid, catalog it, and move on, without necessarily associating it with the interstellar visitor that passed through months prior. The Galileo project is actively seeking such phenomena. This research initiative, funded independently, is dedicated to identifying technological signatures within astronomical data. One of its primary objectives involves monitoring the skies for unconventional objects, small, rapidly moving entities that do not conform to standard catalog classifications. The project currently operates 3 observatories equipped with all-sky cameras and sophisticated software designed to flag anomalies. Should 3IA have deployed probes, and should those probes subsequently maneuver into orbits that bring them into proximity with Earth, the Galileo project is strategically positioned to detect them. While the vastness of space and the diminutive size of the probes present significant detection challenges, Loeb is diligently pursuing this endeavor. He is treating the Trojan horse scenario with sufficient seriousness to allocate considerable resources to its investigation. An alternative interpretation of this scenario posits that the probes have already been deployed. 3IA may have been present within our solar system for months, even predating its discovery. It is known to have crossed Neptune's orbit in mid-2023, affording it 2 years within the outer solar system before its detection. This extended period would have provided ample opportunity to release probes in the outer regions, facilitating the study of the Kuiper Belt with specialized instruments and establishing a surveillance network prior to approaching the inner system. By the time 3IA was detected in July 2025, the initial reconnaissance phase might have already been concluded. The mothership would then have been executing its final maneuvers, passing through the inner system for a cursory examination of any phenomena the probes were unable to observe from greater distances. If this is indeed the case, we have likely missed the opportune window. The probes are already in position, operational, and, unless they intentionally reveal themselves through transmitted signals or significant light reflection, their presence may remain unknown. Space is immense, and even the inner solar system is extraordinarily vast. A probe the size of an automobile could orbit the sun for decades without detection, particularly if its location is not precisely known. And we do not know where to look precisely because we are unaware of their existence. The concept of miniature probes, while seemingly born of paranoia, is operationally sound. A civilization capable of interstellar travel would likely not dispatch a single, large mission to a solitary star system. Instead, it would dispatch thousands of smaller missions to thousands of star systems, adopting a parallel approach. Each mission would be relatively economical due to the reduced size of the probes, and each star system would undergo a survey. The majority of these systems would prove uninteresting, containing only lifeless planets, inert celestial bodies, and nothing noteworthy to report. However, occasionally, a discovery of significant interest would be made. A planet exhibiting an atmosphere, evidence of water, complex chemical processes, or even life or intelligence. Upon such a discovery, the probes would remain, maintaining surveillance, transmitting data across vast distances over decades or even centuries, awaiting the slow journey of information across light years to their intended recipients. Earth, with its abundance of water, life, technology, and radio emissions leaking into space, presents a compelling target. If an interstellar survey detected our signals and recognized our presence, Earth would likely be prioritized for closer examination. This would not initially involve a manned mission, which would be too slow and perilous. Instead, a probe, fast, economical, and expendable, would be dispatched. Such a probe would adhere to a logical mission profile, approach the system, deploy subprobes for extended observation, conduct a close-range pass for direct measurements, then exit and proceed to the next target. 3IA aligns precisely with this profile. Its substantial size, estimated at 33 billion tons, is immense for a comet, vastly exceeding the mass of typical interstellar objects. However, if it serves as a mothership, carrying a payload, and is engineered to endure a million-year voyage through space, its considerable mass becomes understandable. Radiation shielding, fuel reserves, repair systems, and redundant components all contribute to its significant bulk. Our largest spacecraft are minuscule in comparison. The International Space Station weighs approximately 450 tons, while Starship, fully fueled, approaches 5,000 tons. 33 billion tons represents 7 million times the mass of Starship, suggesting not a probe, but something akin to a city, a factory, or a generation ship capable of sustaining a mission across interstellar distances. Alternatively, it could simply be an exceptionally large comet, and the perceived anomalies might be a product of excessive speculation. Nevertheless, the principles of physics remain indifferent to such skepticism. If the object possesses such immense mass, if its existence is confirmed, and if the estimations are accurate, then something must have accumulated that mass. This could be the result of gravitational accretion over billions of years within the disk of another star, or it could be the product of intelligent design, a purposefully constructed entity engineered for a specific function. Gravity forms comets, intelligence constructs spacecraft. Both phenomena are extant and plausible. The crucial question is, which explanation best aligns with the available data? The apparent absence of debris is particularly noteworthy. When comet Shoemaker-Levy 9 fragmented prior to impacting Jupiter, the resulting string of clearly separated fragments, each generating its own coma, was readily observable. Comets, when shedding material, outgassing, or losing mass, produce expanding clouds, tails, and dust trails, visible evidence of disintegration. 3IA, however, exhibits none of these characteristics. Its nucleus remains coherent, its structure intact, showing no signs of fragmentation. For an object subjected to solar heating at perihelion and experiencing mass loss consistent with non-gravitational acceleration, some degree of fragmentation would be anticipated. The fact that it maintains its integrity suggests it is not bound by weak icy bonds, but rather possesses structural strength derived from materials like metal or composites, indicating engineering prowess. The object's stealthy presentation is a cause for concern. If 3IA is artificial, whether a probe or a mothership, it does not appear to be actively concealing itself. It exhibits a coma, a tail, and outgassing, all hallmarks of a comet. It is detectable, trackable, and observable, behaving, or at least convincingly mimicking, a comet to evade casual scrutiny. But why adopt this pretense? Why not simply remain a dark, inert object? The generation of a coma could serve multiple purposes. One possibility is thermal regulation. If the interior maintains a high temperature due to active systems generating heat, this energy must dissipate. While radiating heat into space is one option, sublimating surface ice offers another method, utilizing phase change to carry heat away. The coma could function as a cooling system, with the outgassing being an intentional, controlled process designed to manage temperature while simultaneously providing a degree of camouflage. Another perspective suggests the coma is not for concealment, but serves as a signal, a means of announcing its presence, communicating, "We are here, observe us." The famed "wow" signal might have been an initial announcement, with the coma representing a continuation of this communication. They may not be hiding, they may be advertising. Predictably, we find ourselves debating the significance of this announcement. The upcoming December observations will be pivotal. If 3IA has indeed released probes, and if those probes are following trajectories that bring them near Earth, we may detect them. The Galileo project will be diligently observing, as will amateur astronomers equipped with the appropriate instrumentation. The fundamental question remains whether there is anything to detect, and if so, whether we will recognize it. A small object, registering as a few pixels on a sensor, moving at high speed and uncatalogued. Is it a probe, a stray rock, or a sensor error? The challenge of detection is not solely technical, it is also psychological. We tend to perceive what we anticipate, filtering out extraneous data, anomalies, and anything that deviates from established patterns. A probe, unless behaving in an overtly artificial manner, might easily be dismissed as noise. The Trojan horse hypothesis is undeniably unsettling. It suggests we are being observed without our consent, studied like specimens by an intelligence we do not comprehend and cannot communicate with. It implies a position of vulnerability. If they are present and have been observing us, they possess knowledge about us that we lack about them. This grants them an information advantage, and information is power. However, discomfort should not be grounds for dismissing the hypothesis. If it aligns with the data and offers a more compelling explanation for observed anomalies than alternative theories, it must be taken seriously. The potential consequences of disregarding this possibility are too significant to ignore, particularly if the truth proves unsettling. The scientific community is experiencing a profound division, a civil war of sorts, concerning 3IA, with the lines of contention extending deeply. On one side stands Avi Loeb, a Harvard professor willing to articulate views that many of his colleagues hesitate to express. Opposing him, is the established scientific mainstream, the peer reviewers, the grant committees, and those who wield influence over funding, academic appointments, and publication. Occupying the space between these poles is a growing contingent of scientists who harbor private doubts, acknowledging the presence of anomalies and recognizing the strangeness of the situation, but who feel compelled to remain silent due to the significant professional risks involved. Loeb has intentionally positioned himself as a focal point, fully aware of the repercussions. When Oumuamua passed through our solar system in 2017, he proposed the possibility of it being artificial, perhaps a light sail or advanced technology, publishing papers, a book, and extensively discussing it on various media platforms. This stance was met with strong disapproval from the scientific establishment, who accused him of sensationalism, abandoning scientific rigor, and promoting speculation over empirical evidence. They argued that his actions lent credence to conspiracy theories, undermined public trust in science, and cast astronomers in an unprofessional light. While some of this criticism may be valid, Loeb's provocative approach, his tendency to frame issues in binary terms, natural or artificial, and his emphasis on low probability scenarios without fully acknowledging more probable explanations, are points of contention. Some criticism stems less from methodology and more from the implications of his message. The scientific establishment is reluctant to discuss extraterrestrial life, not necessarily due to closed-mindedness or outright dismissal of the possibility, but because of the field's historical entanglement with pseudoscience, such as UFO sightings, ancient astronaut theories, and crop circles. Astronomers have spent decades striving to establish credibility and distance themselves from such unsubstantiated claims, setting rigorous standards for evidence and scientific inquiry. When Loeb suggests that 3IA could be a spacecraft, presenting anomalies and calculating probabilities publicly, he is effectively reopening a door that the establishment worked diligently to close, and they resent this action. Jason Wright, an astronomer at Penn State who is himself involved in technosignature research, has detailed his reservations regarding Loeb's methodology. Wright, through his blog, meticulously examines Loeb's claims about both Oumuamua and 3IA. While not outright dismissing the artificial hypothesis, Wright contends that Loeb tends to jump to conclusions, overlooks natural explanations that adequately account for the data, selectively chooses anomalies, and downplays inherent uncertainties. Wright characterizes Loeb's approach as driven by a desire for personal validation, rather than a pursuit of objective truth. This sentiment is echoed by numerous prominent astronomers, often expressed in private conversations or carefully worded online posts. The frustration is palpable. Loeb publishes papers positing the existence of extraterrestrial technology, prompting journalists, funding agencies, and university administrators to question other astronomers about their views on aliens. This forces them into a public stance, either endorsing Loeb's speculation or distancing themselves from it. Most opt for the latter, offering cautious statements such as, "The most probable explanation is natural. Further data is required before drawing conclusions," or asserting that the artificial hypothesis is premature. These are safe, politically acceptable, and professionally non-threatening responses, yet they are also vague and non-committal, typical of attempts to avoid controversy without directly confronting the evidence. Enter Elon Musk, the world's wealthiest individual and CEO of SpaceX, a figure renowned for accomplishing feats deemed impossible by the establishment. Musk possesses a long-standing fascination with space, existential risks, and fundamental questions regarding humanity's future. As 3IA gained media attention and Loeb appeared on popular podcasts, Musk took notice. He publicly commented on the matter, suggesting the possibility of aliens and questioning NASA's silence. Deeming the observed anomalies worthy of serious consideration, he amplified the story to his vast online following, transforming it from a niche astronomical topic into a mainstream, viral phenomenon discussed by individuals outside the regular space news audience. The establishment's reaction is one of deep displeasure. Firstly, they resent the involvement of Elon Musk, who, despite his significant influence and success, is not an astronomer, lacks formal training in the field, and has no peer-reviewed publications on comets. His intervention shapes public perception, and his pronouncements, due to his platform, carry more weight with the public than those of actual experts. Secondly, they are displeased by his validation of Loeb's views, which lends credibility to the artificial hypothesis by association, making it more difficult to dismiss as fringe speculation. However, Musk's perspective holds merit. The data surrounding 3IA is indeed peculiar, as is NASA's reticence and the astronomy community's reluctance to engage seriously with the artificial hypothesis. While not an expert in astronomy, Musk is unburdened by the constraints of academic science norms. He can voice his opinions without concern for tenure, grant funding, or editorial rejection. His assessment, it appears, is that something is amiss and warrants public attention. The division extends beyond a simple disagreement between Loeb and his peers. It touches upon a fundamental question of how science addresses anomalies, how it accommodates hypotheses that challenge established paradigms, and how it balances skepticism with intellectual openness. Science is inherently designed to be self-correcting. When evidence diverges from the prevailing consensus, the consensus is expected to evolve. However, this transition is often slow, arduous, and met with resistance at every stage. As articulated by Thomas Kuhn, paradigms do not shift easily. Scientists, being human, have vested interest in existing frameworks, careers built upon foundational assumptions that may prove erroneous, and identities intertwined with theories they have defended for years. A paradigm shift necessitates admitting past errors, a prospect few are eager to embrace, particularly in a public forum and concerning a matter of such magnitude. Loeb is actively forcing this issue, refusing to await the protracted process of peer review and consensus building. He is taking his arguments directly to the public, to policymakers, and to anyone willing to listen, a strategy that has succeeded in generating discussion, encouraging contemplation, and prompting demands for answers. Paradoxically, this approach is also backfiring. The establishment is reinforcing its positions, doubling down on natural explanations, and portraying Loeb as a sensationalist seeking attention by distorting scientific findings. The reality likely lies somewhere between these extremes. Loeb is not entirely correct. Some of his probability calculations are debatable, and certain assumptions are questionable. He exhibits a greater degree of certainty regarding the artificial hypothesis than the available evidence warrants. Nevertheless, he is not entirely wrong either. The anomalies are genuine, and the questions raised are legitimate. The mainstream scientific community's reluctance to seriously engage with these questions represents a deficiency in the scientific process. There's a generational dimension to this conflict. Loeb, being an established professor with tenure and financial security, can afford to take calculated risks. Younger scientists, such as postdoctoral researchers and assistant professors working on 3IA, who are actively publishing papers and applying for grants, cannot afford to be associated with the alien hypothesis, as it could be career-ending. Even if they privately suspect Loeb might be onto something or observe anomalies that spark their curiosity, they are constrained from voicing these thoughts. Their mentors would likely discourage such expressions. Their colleagues might judge them unfavorably. Grant reviewers might reject their proposals, and journals might refuse their submissions. The system inherently penalizes speculation and rewards caution, leading to caution becoming the default approach, even when bold inquiry is warranted. This is precisely why Loeb advocates for federal funding for extraterrestrial intelligence research, extending beyond SETI's passive listening for radio signals to encompass active investigation of anomalous objects, technosignature searches, and missions designed to intercept interstellar visitors. He asserts that the public desires such endeavors. Current public sentiment consistently indicates widespread fascination with extraterrestrial life, a strong endorsement for dedicated research efforts, and a belief in the significance of this inquiry. However, those in positions of authority, such as the committees that control NASA's funding allocations and the peer reviewers who determine the viability of research proposals, do not grant this pursuit high priority. Their rationale is that such investigations are overly theoretical, fraught with uncertainty, and likely to represent a squandering of resources. Consequently, our investment in this area remains insufficient, leaving us unprepared when phenomena like the object designated 3I Atlas emerge. We lack the necessary infrastructure, and the institutional resolve to conduct a thorough investigation. The involvement of Elon Musk could potentially alter this dynamic. Should SpaceX elect to engage in this endeavor, and should Musk commit resources to observing 3I Atlas, to sponsoring missions intended to intercept future interstellar objects, and to developing instrumentation for detecting technosignatures, he could entirely circumvent the established academic gatekeepers. Private capital injects a transformative element into the research landscape, enabling investigations that institutional science might deem unsuitable, hypotheses that peer review would likely dismiss, and projects that NASA would never prioritize. Whether this paradigm shift is beneficial or detrimental hinges on one's viewpoint. It is advantageous if one perceives the current scientific establishment as overly conservative, excessively slow, or unduly resistant to groundbreaking changes in understanding. Conversely, it is disadvantageous if one believes that scientific exploration necessitates oversight, peer evaluation, and the inherent safeguards provided by institutional scientific practices. This internal conflict will persist. Proponents will continue their advocacy, skeptics will maintain their resistance, and Musk will amplify the discourse. Meanwhile, emerging scientists, those not yet aligned with a particular stance, will observe and deliberate, attempting to discern the true direction of the evidence, seeking to navigate the polarized viewpoints, and striving to conduct scientific work within an environment increasingly shaped by political considerations and personal narratives as much as by empirical data. The month of December is poised to be pivotal. As 3I Atlas becomes fully observable and new observational data becomes available, one faction will gain greater persuasive power. If the observed anomalies are satisfactorily explained by natural phenomena, and if conventional explanations prove valid, it will vindicate the established scientific consensus, and they will likely cite this outcome as a cautionary tale against unchecked speculation, underscoring the importance of peer review and the dangers of premature conclusions. However, should the anomalies persist, if new ones surface, and if the data continues to suggest an artificial origin, it will validate the dissenting viewpoint. The scientific establishment will then be compelled to confront their reasons for such staunch opposition, their dismissal of the evidence, and their prioritization of maintaining existing paradigms over the pursuit of truth. Regardless of the eventual outcome, this internal scientific discord will leave lasting impacts: fractured relationships, tarnished reputations, and eroded trust. Such are the consequences of conducting science when the implications are so profound, especially when the fundamental question extends beyond merely identifying 3I Atlas to understanding its implications for humanity, should its nature deviate from expectations. December 19th represents our final opportunity to ascertain the truth. The 11th of November marks its reappearance. 3 Atlas will ascend once more into the pre-dawn sky, emerging from behind the sun, once again within the reach of Earth-based observatories. Following a month obscured by the sun's glare, observational efforts will recommence. Spectroscopy, photometry, and astrometry, every instrument trained upon this object, will gather data, refine our comprehension, and propel us toward a definitive answer. Yet November 11th is not the culmination. It signifies the commencement of the final phase, the decisive moment. The point at which we will comprehend the true nature of this celestial body arrives on December 19th. December 19th is scheduled for its closest approach to Earth at a distance of 1.8 astronomical units, equivalent to 269 million kilometers, or approximately 68 million miles by terrestrial measurement. 3 Atlas will not be perceptible to the unaided eye. A telescope with an aperture of at least 8 inches, and likely larger, will be requisite. However, it will be at its nearest conceivable proximity to our planet. Its apparent angular size will reach its maximum, and the time taken for light to traverse the distance will be at its minimum. If we are to acquire high-resolution imagery and discern surface features, details that could definitively resolve this matter, December 19th is the opportune moment. The celestial alignment is favorable. 3 Atlas will grace the morning sky, rising before dawn and positioned away from the sun, thus mitigating any issues with solar interference. Observatories across the globe will possess unobstructed views. The Hubble Space Telescope will conduct observations. The James Webb Space Telescope will also observe. Ground-based facilities in Chile, Hawaii, Australia, and indeed any location with clear skies and capable instruments will participate. The resulting data stream will be immense, encompassing spectral analyses from ultraviolet to infrared wavelengths, time-resolved photometry to detect variations in brightness, rotation, and potential outgassing events, and high-resolution imaging to map the comet's structure, identify jets, and search for any anomalous characteristics. Should 3I Atlas prove to be a natural comet, December's observations will confirm this, revealing expected chemical compositions, brightness patterns adhering to established curves, and accelerations consistent with outgassing processes. The anomalies will likely be attributed to misinterpretations, measurement errors, or incomplete theoretical models. In such a scenario, we will gain valuable insights into interstellar comets, their formation mechanisms in distant stellar systems, and the diversity of their chemical makeup. Consequently, scholarly papers will be published, scientific careers will advance, and the field will progress. However, if its nature is indeed unnatural, December's observations will also reveal this. The observed acceleration will not correlate with outgassing phenomena. The chemical analyses will remain inconsistent. New anomalies will emerge. The object will exhibit behavior, perhaps subtle, perhaps minor, that cannot be attributed to passive reactions to solar radiation, such as a course correction, a modification in its rotation, or an emission that does not align with any known molecular transition. At that juncture, we will possess a high degree of certainty, though not absolute proof that silences all doubt. Nevertheless, the confidence in our findings will be sufficient to fundamentally alter the discourse. The central question will no longer be whether 3 Atlas Mishab might be artificial, but rather how humanity will respond to such a revelation. Professor Avi Loeb's observational campaign extends through January, encompassing 2 months of coordinated observations that will feed into a centralized analytical process. If 3 Atlas deviates from its predicted trajectory, and if astrometry reveals systematic positional discrepancies not attributable to non-gravitational forces from outgassing, the campaign will undoubtedly detect such deviations. The precision of the measurements is exceptionally high, with minimal error margins. Any deliberate maneuver, however slight, will be conspicuously apparent. Should such an event occur, and should Professor Loeb's observations provide evidence of controlled flight, predefined protocols will be initiated. This will involve escalation procedures, high-level briefings, and critical decision-making processes that transcend the scope of academic astronomy departments and observatory directors. The high-resolution imagery, potentially released by that time, cannot be indefinitely withheld by NASA, as bureaucratic processes will eventually resume and data will be disseminated. When these images are finally made public, offering a view of 3I Atlas from 30 million kilometers away, with 3 times the resolution of the Hubble Space Telescope, we will gain another crucial piece of the puzzle, perhaps the decisive one. If the surface appears to be composed of ice and rock, and its morphology aligns with that of a natural nucleus, it would strongly support the cometary hypothesis. Conversely, if the surface exhibits a smooth, metallic, or geometric appearance, it would irrevocably alter our understanding. Professor Loeb will be observing intently, as he has stated. The Galileo Project's observatories will be actively engaged, scanning for any unusual phenomena, any potential deployed probes, or any movement inconsistent with natural behavior. If 3I Atlas release smaller probes during its perihelion passage, and if those probes are now on trajectories that bring them near Earth, December is when we might detect them. Such detection presents considerable challenges, as these objects would be small, faint, and fast-moving. Nevertheless, Professor Loeb is pursuing this possibility, investing resources in the chance that we are not alone, that we are being visited, and that this epoch could be defined by such a discovery. The public will also be closely following these developments. This narrative has already transcended the confines of academic astronomy, permeating social media, mainstream news outlets, and everyday conversations. Public curiosity is palpable. People are seeking answers about the nature of 3 Atlas, its potential extraterrestrial origins, and the implications of such a discovery. The demand for transparency is mounting. Neither NASA nor the European Space Agency can maintain silence indefinitely. At some juncture, an official statement, a comprehensive assessment based on the totality of the evidence, will be necessary, and that declaration will carry significant weight. If the statement confirms it as a natural comet, the public will largely accept it. However, if it suggests anything otherwise, the world as we know it will fundamentally change. December 19th also carries temporal significance. Following its closest approach, 3I Atlas will commence its prolonged departure from our vicinity. It will recede from the Sun and Earth, venturing toward the orbit of Mars, then Jupiter, and eventually beyond. Observations will become increasingly difficult as the object dims and its apparent angular size diminishes. By the time it traverses Jupiter's orbit in March 2026, it will be exceedingly faint, necessitating the use of powerful telescopes and prolonged exposure times. Subsequently, it will depart the solar system, re-entering interstellar space, never to return. This is not analogous to an asteroid with a predictable orbit that we can revisit in subsequent years or study across multiple transits. 3I Atlas represents a singular opportunity. Whatever knowledge we acquire between now and March will constitute the entirety of our understanding. The window of opportunity is rapidly closing, and this urgency is a driving force behind the scientific efforts. There's a palpable recognition, even among the skeptics, that this event is of paramount importance. Regardless of its ultimate classification, 3 atlases is an extraordinary and valuable phenomenon, warranting the allocation of all available resources. The James Webb Space Telescope, with its considerable operational costs, allocates its observation time through a highly competitive process, prioritizing projects that have undergone rigorous peer review. 3 Atlas is receiving this valuable time not due to universal belief in its artificial origin, but because the scientific community acknowledges the unusual nature of the data and the uniqueness of the object, necessitating a comprehensive understanding. The December observations will also serve to test predictive models. Professor Loeb has put forth several predictions, suggesting that the object's acceleration should continue, that its nickel emission should persist, and that its blue hue might reappear if it undergoes further heating. Should these predictions prove accurate, and should the observational data align with the expectations of the artificial hypothesis, it would constitute compelling evidence, though not definitive proof. Scientific progress is intrinsically linked to predictive capabilities. Naturalistic explanations also generate predictions. The cometary hypothesis posits that the acceleration should diminish as solar heating wanes, that the nickel emission should dissipate, and that the object's color should revert to red or gray as its coma disperses. December's data will reveal which predictions hold true, which falter, and whether the evidence leans towards a natural or artificial explanation. Furthermore, there exists a political dimension to this unfolding situation. Should December's findings confirm the anomalies and tilt the evidence towards an artificial origin, governments will undoubtedly respond, albeit discreetly behind closed doors. Intelligence agencies will be briefed, military commands will assess potential threat levels, and diplomatic channels will be activated. The United Nations framework, under which the Galileo project operates, will be engaged. Protocols for such scenarios exist, having been developed decades ago when initial considerations were given to the implications of contact. These contingency plans have yet to be implemented. December may well serve as their inaugural test. Finally, there's the philosophical dimension. If 3 Atlas is indeed artificial, it implies that humanity is not alone in the universe. This single statement, profound in its simplicity, fundamentally reshapes our understanding of the cosmos and our place within it. For a considerable time, many have harbored an assumption that intelligent life is widespread, that civilizations proliferate across the universe. However, assumption is distinct from verified knowledge. If December provides us with such knowledge, confirming the existence of intelligence beyond Earth, its capacity for construction, its exploratory endeavors, and its direct visitation to our planet, then everything will change. Our religious doctrines will require adaptation, our philosophical frameworks will need expansion, and our political structures will have to acknowledge that humanity is not the sole sentient species, nor the apex of creation, but merely one among many. This transformative shift will be profound and will likely require generations to fully comprehend. Its genesis, however, lies in December, with the accumulation of data, the conduct of observations, and the moment when speculation yields to certainty. I wish to be unequivocally clear on one point. I do not possess definitive knowledge regarding the nature of 3 Atlas. I have presented the available evidence, including the observed anomalies and the arguments presented by both sides. I have endeavored to maintain objectivity, giving due consideration to naturalistic explanations and acknowledging the inherent uncertainties. However, I confess to a personal bias. I ardently hope for an artificial origin, not out of a desire for extraterrestrial contact itself, nor due to any specific agenda, but because the alternative, a universe largely devoid of intelligence, where life and sentience are exceptionally rare, leaving humanity effectively alone, strikes me as profoundly uninteresting. I aspire for the universe to be a more captivating place, a place populated by other civilizations. I wish for the narrative of humanity to include a chapter detailing our encounter with them, the realization that we are not singular, and the subsequent transformation of our worldview. 3I Atlas, with its 9 anomalies and its astronomically improbable odds, represents the most compelling opportunity I have encountered in my lifetime for the universe to bestow upon us such a narrative. December 19th is 46 days from this moment. 46 days until we possess clarity, until the data is compiled, the analyses are finalized, and conclusions are drawn. 46 days until we ascertain whether 3 Atlas is a comet or something far more extraordinary. 46 days until humanity either confirms its solitude or discovers that it has never been alone. This is a remarkably short period, barely sufficient time to prepare for whatever lies ahead, regardless of the eventual revelation. Nevertheless, it is the time we have been allocated, and we shall utilize it fully. Telescopes will focus their lenses, scientists will meticulously analyze the data, and the public will observe with anticipation. On December 19th, 3Y Atlas will pass within 1.8 astronomical units of Earth, carrying its enigmatic secrets and revealing whatever truths it holds. We will be here, looking skyward, posing the very question that has defined our consciousness since its inception. Are we alone? The answer, in one form or another, is imminent. Thank you for your attention. If this presentation has provided you with food for thought, please consider liking this video, subscribing if you haven't already, and sharing it with anyone who might benefit from its insights. The universe is vast and boundless, brimming with endless mysteries. Periodically, however, one of these enigmas draws sufficiently near to be perceived. 3 Atlas embodies such a mystery, and we are living through the very moment of its revelation. Do not avert your gaze. This is history in the making, and you are an integral part of it. As always, the information I present is grounded in current scientific data and analysis. However, I am not a professional astronomer, and my interpretations should not be regarded as definitive. I encourage you to engage in critical thinking, consult multiple sources, and follow the evidence wherever it may lead. Until our next encounter, continue to look up. Good evening.